that should be the stream up and running. I need refresh my stream thing so I can. Nope, chat's still broken. Okay, I don't know what's wrong with it, but it says that the chat is broken. Just probably means that I have switched accounts and somehow stayed logged in. Let's try that. Okay. Oh, hopefully you guys can all hear me and I'm still working properly. So doing more admin of code because that's what the results of the polls were. So like 2/3 of people voted for admin of code, a third voted for the Minecraft clone, but you didn't win. So and nobody voted for Untitled Dinosaur Game. So apparently you guys don't get to see the development of that. Been working on it off camera, and made a really cool map. But you guys voted wrong. So we're doing advent of Bevy. I'm not going to bother with the story in the streams because I think it bogged down too much. Like I'm using it as inspiration, but I've already looked at the next 2 days just to try and get more of the advent done in a single stream rather than me messing around pages trying to work out what I'm going to do. So this one is they've got like a computer program that's faulty and is got corrupted memory, and we have to go through and work out the correct values. So we have to go through and pass for only valid occurrences of mul followed by an open parentheses, followed by up to 3 digits, followed by a comma, up to 3 digits, close parentheses. And that's all we're looking for. So there you can see it's corrupted, and then we're ignoring things like do not, and then we're ignoring this one. Like we're not fixing the corruption. So they give us some examples here of like question mark. So we're not doing anything that's not valid. It's not like we're stripping out invalid characters. We're only finding exact matching characters. Even weirdly enough, white spaces are incorrect. So it's more or less a passing challenge. So what I was thinking we can do, and then we're going to sum the results. So we do the multiplications, is using the same sprite as we did in day 2 for the little computer monitor of the reactor. We can run a thing. So if we launch the code, this might take a while to compile. We'll write like a program using Bevy's new scroll feature in there, like no data. Weird. I don't know what's wrong with the stream. Okay. So the idea is the Bevy has a new scroll component so that you can have like a flex box that overflows into scroll. And the idea being that as we pass it, we'll put each instance of a multiplication and not everything else until we find the next instance of multiplication. We'll go into a entity with a bunch of text, and then basically we'll have it scroll past over the course of like 3 seconds and then have the answer at the bottom. As if it was running like a console command, and it was like I want to say like CMD tree, like that kind of effect where it's just sort of zipping past without actually meaning anything, and then at the last value we'll have it be like whatever it is. Yeah, hopefully that did not have anything sensitive in that tree, because I did not think that's true. So it's compiling, so I guess we'll write some code while it's compiling. Day 3. I've already got the data entry here, the value here, so we basically why, how, okay, so there's a valid one there. So we go here. So on this console, we're just going to have it like spew out all the values and then like scroll past. Don't know how well it'll work. We will see. It may be too much flashing lights, who knows. So day 3, first thing we're going to do is pass all the values. So we need to have output is going to be a vector. New, and it's going to be like a vector of strings, I guess. I don't know. That's also an H for output. Okay, so then we're going to go. I think we need to. We're gonna have to like pass it like bit by bit, because if we don't, it's going to have issues. Like if we try to like extract it with a regular expression, which I'm assuming is what they intend this be solved by, is just a regular expression that's searching for a very specific set of things. Instead, we're just gonna write our own thing. So this is gonna let word equal, and it's just gonna be a string. No. So then we're gonna go for char in data.0.chars. So iterate through every character, and then we have very, very simple formatting. So we need a like an enum state, I guess. Stage, and it's going to be mul. This is mul, right? Mul. The word we're looking for, mul. Yeah. So mul. Then we're going to be open val one. I guess val one, val 1 to val 1 3, because it can have up to 3. Unnecessary like complexity there, but like I think it's more interesting to solve it this way. And then we go comma, then we go val 2 1. Okay, 2 2 2 3, and then close. Right. So that's going to be our state. And we're going to go up here. We're going to say let so new state is equal to state or stage. And then we're going to start in stage mul. So the first thing we're going to do, well, actually, technically it should be we are M, and we're U, and we are L, like that. I reckon it will look better, because that's the only multiple stage word. So the idea being that we go we're going to need, I guess this is going to be a visual output, so text output. So that's purely not related to solving the puzzle, that's just about visualizing it at the end. And then we'll have an actual output, which is a I guess we need to go like let num because we actually only care about the numbers. So num1, and that's going to equal 0. Let num2 equals these need to be strings, don't they? God damn it. Actually no, they can just be numbers. We just have to multiply them. So u as being 0, u as being 0. So we have our word. Output is just going to be again a vector. No, the output is going to be a number. So what we need to do is go. I guess. Again, it's me like. I guess practicing my own like Rust code of trying to write interesting code. So we'll match each state, and we're going to go. Okay, we're in the state M. So if we're in the state M, if char equals u, and I think it's only lowercase. I'm not 100% sure. Case sensitive. Is there any capital M used? No. Okay, so we don't have to worry about case sensitivity because there's nowhere where the capital letter M shows up at all in the test data. So if it's U, then state or stage equals stage U. Okay. And then if we're in that state, we don't care if it's anything else because we don't need to reset. So then we go, if we're in state U, if char equals L, we set stage equal to stage L. Else we set stage back equal to stage M. We could probably tidy this up. I'm thinking if I want to do like a thing so that I'm not writing lots and lots of code. So if char equals so next we would be looking for an opening parentheses, and we just say stage equals stage open. Again, else we set. This is really easy because it's specifically saying anything. Like, we don't have to worry about white spacing, we don't have to worry about checking anything like that. So we say stage equals, and no doubt the next thing will be that. Hence, I'm kind of thinking what I want to do is go here and implement stage, like import stage. I'm gonna go fn. And then we say like state or effect, and then that's gonna take in a boolean. Like this, and we say if val else, you need to take immutable self. And then we say, and I guess you return a boolean, and you're just going to return a val at the end. The idea being that I can just pass in the thing and then react on it if I need to. So the idea is, okay. So we want to say dereference self equals stage m. So if you pass in a false value, then reset yourself. Then we say it's match. Well, I guess it's self equals match self, like so. So m is stage yeah, I'm doing all right. Glad you could make it to another stream. I don't know if I'll be doing it like a long hour, 8-hour one again, but who knows. I'll get at least 2 days of the Bevy Advent done. It would have been nicer to be able to do more. No, I don't mind. Technically speaking, it's the way my name gets abbreviated is PH Fox, like it because the PH sound makes the first sound, and it's just like a play on the fact that the beginning of the name is PH, and therefore you sub out the Fox. But that doesn't really bother me. That's just like a comment of like, if you're writing my name so that other people know you're referring to me, it's PHOX. But again, that's just something that I do, and I've noticed other people do. So next is you. Stage. Next is L. Stage open. Nope, not open. Mute. Open. Open. Why do you keep doing that? And next is stage value 1. Now this is where it gets a bit tricky, because these ones technically aren't necessarily the increment. Value 2, stage phase 3. Yeah, I mean that's up to you. Yeah, so it's just when I write it, it's PH Fox, so that like people know that I'm referring to myself. I guess I don't know, but yeah, it's personal preference. I don't really care. The big thing is I know who you're talking about because you write it, I say it. I do find it funny that some people like have that weird thing where they're like, "Oh, you said it wrong." I think, well, as long as you know what I mean. Like, my issue is I can't spell. And so a lot of times when I say things, like when I write things, people go, like, what the fuck does that mean? I'm like, say it out loud. Like, read out aloud. Like, if you didn't know how to spell, like, sound it out and you'll probably know exactly what I mean, because it doesn't make sense written down, but it makes sense said aloud, and that's how I communicate most of my shit, is said aloud. So yeah, if it is something I write doesn't make sense, say it out loud, and then you might go, oh yeah, I can see. Stage. So the next is closed. Next is closed. Okay, and then this one would be stage W. M, not W, M. So that's a nice loop there. So next, I guess we need to say offense skip. The idea of the skip being that so mute self and I guess it's just skipped. It's just an actual effect. So you just say match self. I'll reference of given self equals match self. We don't need to do all of them, so these should all not work. Do I need to upgrade? Oh yeah, is it got a fucking? Oh, let's not open that actually. No, Windows does have an update. Okay. Be honest, not worried about that. I should update my PC. More a security vulnerability thing, but like, yeah. So these should all just return. I guess it's if the value is 1, which is what we're looking for. First off, you shouldn't be able to skip 1. It's if it's 2. Or 3, skip to comma. The idea being that then we do that. So that's correct. Then we again say you can't skip at the first value, but if it is value 2 or value 3, like so, and then everything else should just warn. Don't skip and then return. I guess it's A. We need to say A, and then we go up here and we say you implement derive debug. I had that, but okay. And then we go here, we go here, and then you need a comma. So, all right. So value 2 and 3 of the first value can skip to comma, and value 2 and 3 can skip to closed. And then anything else just sets itself to a bit and goes, you're not supposed to skip this. It's more of a like debug warning to me if I fucked up. So then instead we say state.effect char equals M. Okay, and then we don't do any side effects, hence effect. Do effect and then do effect, but except you are looking for the letter U. You're looking for the letter. Wait, no. What? Yeah. You're looking for the letter M, and you're setting it to L. You're looking for the letter U, and yeah, setting it to U. And then you're looking for the letter L, and you're setting it to open. And then open is looking for the letter. I guess it's just state.effect char equals open, and then value 1. This one gets a little bit more complicated. This one is if state.effect char.is numeric. Right. So now we actually have to do a side effect. Right. So if you work. And then I guess technically these all do the same, but annoyingly we have to do duplicate code because these actually pass in a specific multiplication value. So, well, actually, no, technically these could all be the same. So we say Oh, no, these all do need to have the side effect of resetting. It's not output, it's number. I guess if we go into value 1, we need to first say, you can have the side effect. If you set this, please set, so we need to wrap this in parentheses. Let me say, actually no, if, there. Okay, and then we say number 1 equals 0. This is because I'm trying to make this like generic code, like reusable. So we can say if 1 or 2 or 3, right? If we're looking for a value 1, 2, or 3, do exactly the same thing. And it should work. In my head, what I'm thinking is we say num times equals 10, because what it is if we find a first digit, the value is already 0. So we multiply nothing by 10 and we get the same digit. If we find a second digit, it means the first digit was actually in the tens place. So we multiply that digit by 10 and then we add the extra digit. And then finally, if we've got a third digit, it means that the first digit was actually a hundreds place. So we multiply it again by 10. The second digit was actually in the tens place. So we multiply it by 10 and then we add the final value. So in theory, all 3 of these should work without needing special code, because the way is each subsequent digit multiplies the previous digits by 10 and adds itself. So then we say num1 dot no plus equals match char. Okay, match char, and then we say this is just so if it's 0, we return 0, and then if it's 1, 2, 3, 4, 5, 6, 7, they're all going to return 0 for now. I'm lazy. 7. So then we go. Why is this not your shift? Oh, okay. 8 and 9, and then we just go something like this. Control C, go over here. Like this, Control V. Okay, so simple passing without having to worry about potential failing of passing, and then we say anything else. We should probably just panic here because A is not numeric, because like you shouldn't be able to get here. We should say unreachable, not unreachable. Okay, so it's unreachable because A is not numeric, and it's like, yeah, it is. Then we can do exactly the same thing here, where we go, you are both bored, and then you are this logic. The only difference being that this logic needs to say you're actually number 2, and you're also number 2, like so. So again, simple logic, passing this a comma. So you are stage dot effect. Ooh, no, these need to also check. Okay. So is numeric. So we actually need to not check that. We need to say if char dot is underscore numeric. Right. So we need to do that, and we need to say and then we need to go else if char equals comma. This may not work anymore because I think technically, and it depends how like sneaky they are with the generation of the generation code. We need to say state.skip. What I'm thinking here is that it's potentially possible else state dot reset. I have a reset. Okay. It's possible that they've gone through and specifically put in the Okay, yeah, you don't need to return this. You just because we need to dereference A. Can't. It needs to be copied. Clone and copy. Yep. Now you could be dereferenced. I think no. Okay. You're done. Can we dereference it here as well? There we go. Now we can just return A. There we go. Okay, fn reset. I keep forgetting what I was talking about. So if they're being really sneaky, they will specifically include somewhere in the test data cases that fail, like these edge cases, in that it's possible that there might be 4 numbers and then a comma, which this should be fine because it specifically checks for 1 number, 2 number, 3 number. If it gets to 4 numbers and finds another number, it doesn't run this logic. It runs this logic. Now, the issue is that calling skip needs to not take you to comma. It needs to take you to val 2. You see, which means that we also need to say that if you find this num2 equals to 0, which is getting a bit repetitive code wise. Okay, so reset, and reset needs to dereference self and equals stage m. So it's what we're looking for with what stage is. Okay, so if the number, right, and then we need to say something like stage dot effect, and then we just pass in true, right? Right. So if it's a number, we increment its stage, like we increment the effect. If it isn't a number and it is a comma, this is why sort of state 1 needs to be its own thing, because technically it's a failure if it's a no numbers followed by a comma. That's another like edge case that you have to kind of check for. So if it's a comma, this so we can go, if that's not a comma and stage does not equal stage value 1. So if it's value 1, if we're looking for value 1 and we find a comma, don't do this, because that would be a case that I would definitely include in every data set, is at least one case where 0 values and then a comma is provided, which is invalid. So clone copy ipapara equal. Right. So we're specifically checking for that use case. And then we're skipping if we find a comma, and we're resetting. Right. So now, interesting thing here is we have to do the same logic here. So comma effect is that you are char equals not equals comma. Right. How do these other ones? Just got a semicolon. That's confusing. Okay. Like that. Okay. So if it's comma, check for a comma. Yeah, so any of these 3 can fall back onto the comma check is the issue. Well, actually, stage 1 can't. So technically, it might be better to split them out, but no, lazy. You're the same, but except you need to be val 2-1, because again, same logic. You can't be looking for that, and you're not looking for a comma. You're looking for a closing parentheses, right? So you call skip, and the issue with this is that skip. So we need a final one, which is done. Right. Now, here's a worrying fact. Interesting. Because we need to check again. Right, so if we're looking for close, we need to say state dot effect char equals char equals closing parentheses, like this. We need to at the end here, I guess, check this. Well, no, that's not. Yeah, that's what close does. Right. Getting looped around in my own head now. Right. Do this. Do this, please. Right. So you skip. Okay. So when we skip you, we need to say that you don't go to close. You go to done. Because if you find a closing parentheses, it's finished. Like the second value is done. You actually don't need to reset. No, you just do that. Because the idea being that, oh yeah, that's what you need to do that as well. So num2 equals 0. So we have to reset num2. And then we multiply, we do that. Okay, so we can close. And then we go right at the bottom. So we check each of these. You don't have a state for done. So we should say that stage done returns unreachable. You should not be able to get to done. And then we say if stage done, if let stage done equals stage print line done. Okay, I'm gonna do that for now so I remember what goes there. So the idea is that at no point, so you need to not go, you need to go to done. And then you also need done, and done needs to just go to done. Like you can't cycle past done. All right, so the idea is you should never loop with done being set, because if done is set and you're trying to loop, you're going to skip a character and that could cause issues. So the only way that done can ever be set is if we've literally just found the closing parenthesis, or we were, okay, that's it. The only time done can get set is if the char is equal to closing parentheses, and that will set done. And so what done will do is done is going to say result. We're going to, right, we have word, don't we? So the end of each stage, I think we push word. So word, and then we push, See, the issue is that if any of these are equal to false, so we should say like that you failed equals false. No, it's more like if you ever find the letter M, if this returns true, then we want to say text output dot push std mem take like so. So we're going to take the word, which I believe take resets, replaces it with the default value. Replaces, yeah, okay. Replaces this. So what we're doing is we're basically going to say, hey, if we find the letter M, take the previous word, reset it to default, and store what that word was so we can print it later. And then again, when you get down to here, and then so at the end of each thing, we're going to push char. Right. So at the end of each cycle, push char to the list. And then if we ever reset, all right, don't. It's not if we reset. So we reset multiple times in a row. We don't want multiple lines of fail. Like each letter is on its own line. It's every time we find an M. Yeah, no, that might not work either. Because that means every M, if there's like two M's in a row, they'll get their own line. That's like not really an issue. Because again, like this is just purely for dumb visualization. But basically every time it fails, we want to reset. So basically every time we start a new run, So unless there's two M's in a row, then nothing should end up on its own line. Right, that should be fine. That should be fine. So we take M, we reset that when we find M. Then we say number 2 is overwritten before it's red. Yeah, number 2 is overwritten before it's red. But these are writing it, right? No, these are not. So okay, thank you, compiler, for finding that bug. So yeah, we reset char, we skip, we say you never can reach done. We say okay, so if it is done, we say the same thing. So text output word dot push. Now, what we also want to push is not just the output like that. We want to push that and the word false. It's like just a boolean. We're gonna push boolean false, and then we're gonna go here and we're gonna say boolean that one true, right? So why are we pushing true and false? Because we want to know if the line is a successful line or a false line. So when we render it, we can render it green or red. So if let stage equals done. So then what we need to do is we need to say result, output plus equals num1 times num2, right? Like that. And then we need to say stage.reset. All right, so that should pass all of our values. And I think that parser should work to extract everything we need. We'll double check when it's done. So next we're gonna say, I guess, result for advent, which is going to just be print line copy to advent, like so, copy to advent, and then we're going to paste in output, right, like that. So also when you get out here, say text output dot push output dot toString. No, it's gonna be like format copy advent some like that, and let me say output. There you go. And you also need the boolean value saying that you are true. Okay. I also forgot to jump into Discord and let people know. Oops. Jump in there. Copy. Go to Discord. Oh, go to Discord. There we go. That's it. Okay. Okay. So, all right. So we're gonna push that bit of extra thing here, and okay. So we're gonna go for. Do we have access to the puzzle? Maybe, possibly, not really. It should be fine. So we're gonna spawn something that's state scope like this. Right. So we're gonna go. So commands spawn. Yeah, state scope to our day. Don't load any asset. It's not an asset. It's a I think we just need a node, like so, and then the node is just going to be, probably something like top. This is going to be annoying to place. Val percent, maybe like 10% from the top, and left val percent 10% from the left, and then width is going to be val percent 80%, and then height is val percent 80%. I don't remember how. Okay, overflow. Scroll. Y. Okay, so overflow scroll Y. What does this actually do? Visible scroll. Okay, cool. So that should be our node. and then we say dot with children, not child, with children, key naming conventions and everything. P, so let me say for text pass equals in output text output, right? And then we say p dot spawn if pass. No, it's more convenient to be like p dot spawn text. So we need to do this. It's a text new text comma text color. Okay, so then it goes if path text color. I think it's like this, and then we say if path else. Then we say color sRGB 1 0 0. Okay, and then we say color sRGB 0 1 0. Is that gonna work? No, no comma. Okay. So text color. Well, I guess like value 2 is never used. Even value 2 is never used. Never constructed. Well, what did I copy and paste? Value 2 becomes, oh, yes. You become 2. You become 2. And you become 2. Okay. There you go. Now we should iterate through all of them. Well, we'll know if we have the answer. Yes, I can just run this and see what it puts out when we do our advent and see what happens. Okay, day 3, and we go, it printed nothing. Why did it print nothing? Why did it not pass any code? We did enter day 3, correct? Like, it's not like I'm an idiot and enter day 4. Oh, we have to click 1, don't we? Well, apparently the answer is this, so it's going to go to our advent. Go, is this the correct answer? Did I do it correctly? Yes, okay. We did it correctly. So continue to part 2. Now to work out why it's, oh, it is. Why are you not wrapping though? Like that's what we want, but we need you to wrap. Okay, no, wait. Do I so I need to set something. I just don't know what. It's day 3. We're down here. We say overflow. So scroll Y, but we need to say to overflow. So clip scroll visible. So can I say like X, which is then overflow axis? So you need to clip hide overflow items by clipping, hidden hide overflow items by and then clipping. No, okay. Scroll overflowing items visible. Okay, so we need to say overflow scroll Y, but we need to say like is there another overflow? Overflow clip margin. How the boundaries of clipping content should be determined. Okay, overflow clip margin. No, okay, so it's probably not that. Wrap maybe? Wrap? Flex wrap? flex wrap. Wrap. Is that gonna work? That should work. So I think what our current issue is that we are not wrapping when it goes over the end. So it's just like piling up. Hey. Now it should probably all be on their own line. So another thing is we need to kind of, I like how that, because we can change the size, which we're not supposed to be able to do, we can slightly overflow it. So I'm going to say that 10% on that side seems correct. So we need to go slightly more of those. We need to be like maybe 22%, maybe 15%, and maybe 12. We need to try and, no, that's wrong. So we need to make you be like, so 12%, and that means we need to subtract 4 from you, which makes you 76. Actually, height's probably correct. So height can fit. There we go. So when we say run now, restart the application, please. Should hopefully fit a little bit better in the screen. I wonder if the editor's updated, because that makes this stuff so much easier. So we're going to go to 3, and then we're going to go 1. Okay. So it's not quite there, so it needs to be like 15. So day 3, it needs to be like 15% from the left, which makes you down to 70%. Alright, close you. Run you again. Okay, let's see if the Bevy editor, please, has a new version. Last week, updated examples last week, bumped. Okay, so is there a crate release for it? When did this come out? When did you come out? 2 months ago. No, so there's no crate release, but there is, looks like the GitHub's up to date. So we're going to copy that. Go here, go here. Okay. So it's all fitting that way. We have all the fancy code. So it can't be quite as tall. So it can only take up like, that's looking more like 60%. Anyway, let's whack the editor in. So Bevy editor, please, equals git there. Oh, I've already fucking pulled in the git. I just wasn't using it because it wasn't up to date. So we say add plugins. Wait, what? Was I just copying someone else's? I'm an idiot. I had the fucking edit the whole time. I literally should have seen it at the top of the screen. I am just an idiot. I had the editor the whole fucking time. And I accidentally opened the editor at one point. How did I just like completely stop full screening it? This is what it's supposed to look like. We should probably report that as a bug that you can do that. So we need to go to 3, then we need to go 1, then we need to go, okay. So first off, you show UI. Apparently that doesn't work. So we just need to make it not quite as tall. So I think that's you. No, be this one. Yeah, it's gonna have a lot of children. Node, we need to say height 80%. So 70%. Yeah, it's 80%. Alright, we need to push it over slightly as well. So left maybe 17. Yep, that'll do. Okay, so go here. We're gonna say so we only want to be 70% and 17, right? And then finally we need to do the scroll the screen approach. So we're gonna go fn scroll, and that's going to be and then we need like fn reset scroll, which means we need a resource because now we have to track this thing externally to a specific system. So derive resource. Okay, so struct scroll progress, and it's going to just be an F32. Okay, so scroll reset is going to take in mute scroll, which is going to then res mute scroll progress. No, not position, progress. Okay, scroll progress, and then we come down here and we just say scroll dot 0 equals 0. Okay, and then down here we're going to say we need time, which is res time, and we need progress equals, which is a res mute, because you're going to update it. Scroll progress, and then we need to query for text, which is going to be I think somewhere it's called like, so first it needs to be a query, and it needs to be for scroll position. Scroll position of a node. Update the value of the scroll position will represent the children. The children of the node to be offset amount. Scroll position may be updated by the layout system when the overlay changes, making previous scroll position valid. Changing this does nothing on a node without setting at least one overflow axis to scroll. Okay, so that's exactly what the scroll position. That's also not a word. Okay, scroll position, and then we go for pause in text mute text, right? And then we say we need to make it mutable. That would be smart, wouldn't it? Mute, and then we go down here and we say that. Okay, so very first thing is that progress dot 0 plus equals time dot not text, time dot delta seconds divided by like 5. It's gonna take 5 seconds for it to scroll through everything because arbitrary definitions. So and then we're gonna say if we'll grab the inputs as well. If input res button inputs key code, right? Then we just say if input that just pressed key code space, because I have no idea like how long this is actually going to take. It could take 5 seconds. But they may be zipping past really quickly, but I'm just going to say, like, if you hit space, then progress.0 equals 1, right? And then we're going to progress.0 equals progress.0 clamp clamp between 0 and 1. Cool. So then we need to say pos, and we say pos dot x offset. Now divide by scroll to right. Okay, how far across the node is scrolled in pixels? That is annoying because now we need to know the height of the node. Now, does it actually tell us the height of the node? Like if I go in here and I say node, computed node, it says your size is 500, but that's just the size of you. Like that's not all of its children. Unrounded size. How do I know how big you want to be though? That's just bizarre. Well, that's stacking it. Is there a way to know how big you are? Like node relative size. Like this is supposed to not change. Like this is what the player sets. This is what the or the user sets. This is the computed result. So the fact that it's writing out those values is like that is that size there. Not. Okay, so we could just go to like 1,000, 10,000. I don't know how long is long enough. The x offset equals progress dot 0 times by 1,000. I don't know. that a reasonable amount to offset it by? The other option is we just literally say you're going to scroll at 100 units per second, and then we just get rid of this bit. And then we go plus equal than. So you can skip forward 5 seconds, right? So that's what that can do. So we need to add all of our fancy stuff. So we need to first off, we need to insert resource scroll progress is 0. We need to add systems. So on enter, well, it's more like this one. So this is on enter. Okay, so cool. So if we bundle this one, we say reset scroll, please. Okay, so you reset scroll, and then I think you together, then you become I guess technically update scroll can just run all the time. Since yeah, okay, so we're just gonna go dot add systems on update scroll. Thank you. This should work because I don't think any of this stuff unwraps anything, so it's not dependent on it actually being in the menu. It does technically mean that some days, like as we add more and more days, our fucking advent calendar is going to run slower and slower because it's doing a bunch of shit simultaneously, but that's not going to matter at the scale that this is at. Anyway, so we're going to go 1. Okay, why is your scroll not updating? Question, do you have a scroll? Scroll position. Oh, it's increasing. It's just not actually scrolling. Oh, because it's supposed to be fucking scrolling the Y, aren't we? Yes. Yes, please scroll the Y. That would be very helpful. Scroll the Y, please. Okay. And then we go run. We do 3, we go 1, and we go, hey, look, it's slowly scrolling by. How, where, select, why, how, when, why, what, select, what, when, select, when, why, when, when, from, who, what. Okay, so it definitely needs to scroll faster. Okay, but this can give us a good idea because we can run that again. And then we can go here and we go. So it can scroll a hell of a lot faster. I don't know why there's a bunch of enters in there. Yeah, like with many times faster, like fucking thousands of times faster. This is the thing, is I didn't know what was going to be too fast. So let's go to like 1,000. It's 10 times faster. So it should zip past now. Maybe not, because it was really scrolling. Like, it's at what, a screen every 2.5 seconds, something like that. Look at it go. It's still got a long way to go. Hey, look, it doesn't scroll past the end, so that means we can actually make it go way faster. Okay, so if I make this like 5,000, it's just like 1,000. Actually, just make this add 5. There you go. So and go back to 1,000. So now it's going 1,000 units per second. So that's the equivalent of 5 times again. It's just, you know, why divide by 5 and then multiply by 5. I don't know how long it's going to take to get to the bottom, but it should be like just a few seconds. Yeah, that's what we want. I mean, that's still way too long. Okay. So maybe what we should do instead is keep like a local variable. I guess we should go like this. Give this a second, F2. And then if So I'm going to say instead, if spacebar, we're going to say progress 0, and then we're going to say times by progress 1, and then we're going to say if they press spacebar progress 1, yeah, I guess times equals 5. So we just 5x the speed, but now we need to bring this back down to like 200. We want it to be like somewhat readable as it scrolls past. And then when you reset, you need to also reset the scrolls 1 equals 1. Okay. So yeah. 1, 1. All right. So now when we do it, you do like just plus equal 5 instead of equals 5. No, times equals 5. That's even better because that means that it's going to go. Okay, so it's somewhat readable. Actually, we need to be even slower than that. We need to be like maybe even like 50 units. Because I want it to be like actually pleasantly readable. That is unpleasantly fast. Like it's readable, but unpleasantly so. So we'll make it real slow because it's going to get 5 times faster every time you press the spacebar. So if you just want to get to the answer at the end, which admittedly you just copy out of the console because that's where it pastes it. And then we're at the end. And then it says this, the sum is 1, 6. It's because I can't copy paste it. That's why I post it down here. Cool. That's one data visualization done. Let's go on to part 2 of the puzzle. So my guess is it's going to say we have to like somehow extract the additional shit. Okay, second puzzle. As you scan through the corrupted memory, you notice that some corrupted segments are also still intact. Wait. If you handle some of the uncorrupted conditional statements in the program, you may be able to get an even more accurate result. Okay, there are 2 new instructions you'll need to handle. Do instruction enables future mult instructions. Don't instruction disables future mult instructions. Only the most recent do or don't instructions applies. At the beginning of the program, mult instructions are enabled. Okay. For example, mul, yep, don't, mul, do, mul. Okay, this corrupted memory is similar to the example from before, but this time instructions are disabled because they're, okay, yep, instructions before them. The mult instruction function normally, the one at the end, re-enable, and do, okay, it's time. Okay, yep. All right, so that should be really easy to do. So that's like so similarly to what I had done. I was so expecting it to be something like you have to pass all sorts of weird shit, but instead we can just copy exactly 1 for 1 what we were doing. Right. Apparently with the assets, for some reason, we do not need access to the assets ever. Or the puzzle really. We just need that. Same here. So all we need to do is say let mute enabled equals true. It starts enabled true. Okay. So wait a second. Does the words do and don't? That's a pain, isn't it? Fuck you. God. See, the issue I've just noticed is the word do contain, or the word don't contains the word do, which means that I mean, like it's not likely to pick up on it. Like it's never going to trigger a do, but it means that I can go, and then I need to branch and check for n or a closing parenthesis and continue. So all we really need to do is have a second stage. Oh god, that's going to be fun. So I'm going to paste this down here. Except do's and don'ts don't have any like properties to them, so that's fine. So this is right. So you're going to be the same. So you're going to have a D, an O, an O, an N, a apostrophe. It's apparently not spelled correctly. Okay, we're just gonna say comma because I can't be bothered trying to work out how to spell apostrophe. So we have do, don't, T, right? So you have a state T, so don't, and do is already contained in that. So when we have open and we have close, right? So then you're the same. So D, right? So you're annoying because right. Well, first off, it's we need to replace all of these and just go, don't fucking bother. Okay. Still missing arms. Okay. And we need done as well. Done. Okay. So enabled state done. Okay, this just needs to go back to being enabled state done. So self equals enabled state D. So you'll it's what we're looking for. Okay, so annoyingly, okay, so and all of you guys are replaced with an enabled state. Okay, so you become an O, but annoyingly you don't necessarily become an N. Kind of can't do it this way, can we? I think this one's also less complicated, so maybe we'll just do away with this one. You also don't need to skip the reset. Okay, we're just going to get rid of this whole section. And we'll just track the same parsing logic. So we want to keep a track of an extra character as well. So we need to say it, let mute. We do want to actually leave reset and probably even skip. I think skip is going to say if enable state O and you call skip, go to enable state open. Okay. And then reset is going to set you to enable state D. Okay. So I just want those two functions because they're pretty nice and convenient. So we're going to have, so we need enabled. Okay, this is passing day one data. We don't want to fuck with this one. This is the correct one. Leave that alone. It's down here. So we already have enabled, and then we need that mute enabled underscore state equals enabled state D. All right, so same concept. We match our state. We push our character no matter what. You need to push the character with false and also enabled. Right. You also need enabled. Except, no, you're just going to push through, which is hilarious because technically speaking, it's if enabled. Do that. Else. Oop. Else do it, but say false. Okay, cool. So we're still going to extract all the data. It's just, yeah, okay. So we're going to push the letter and then we're going to go here. We're going to mute and match enabled state. Okay, so if the enabled state is D, enabled state D. Okay, if char equals D. Okay, so if it's D, then enabled enabled state. We kind of need to make this peekable, don't we? Dot peekable. Right. So then, well, I guess an enabled state equals enabled state. So then we go for O, because it doesn't matter what happens, we're looking for O. Then if char, okay, we don't care. So we check D, and then we go enabled state O. Obviously, we're just going to branch, which is kind of a pain in the ass. So we kind of need to keep the let new next equals I guess false. It doesn't really matter, because it's literally when we go here, we go if enabled state if let enabled state done enabled, oh, we need to say equals enabled state enabled equals next. Right. So we're doing this because that sets our enabled state at the end. So if it's O, if char equals O, right, we are going to do some logic else. Enable state dot reset. So if it's not O, reset. Okay, so if it is no, if I think we need to change out of a for loop, don't we? Because we need to be able to peek it. So we need to say you need to be mutable. We need to say while let some char equals chars dot next, like so. Right. So we need to make it, because we need to access the peekable thing. So we need to say if well, first off, if let some next char, and that's going to equal chars dot peek. So we're going to grab the next value, else just info end of string. You can do that because that's literally not going to change anything about this. So if the next char, we have to say if next char equals n, we're going to do enabled state equals enabled state n. So basically we're going to cheat, look ahead and go, hey, if it's n, set it to n. Else. And we don't need to actually check anything else, because we're literally going, hey, will the next one pass? If the next one won't pass, like, therefore we definitely are not in the don't chain, then continue down the do chain, because it's either going to fail the don't chain or it's going to succeed the do chain. Like, we've already concluded it's failed the don't chain at this point. So next we're going to go for open. Right. So that's what that does. So we go D and we go, okay, you pass D, go to O. If you pass O, look what the next character is. If, I fucking can't fucking compare. Fuck off. If the next character is an N, then we could be going down the don't path. So going to the don't path. If it's not an N, we're definitely not in the don't path. So continue down the do path. And then we need to also set here. So next here we need to say next equals false. Otherwise, next equals true. Right, so you do that, and then down here we say next equals true. Right. So if the next character is an N, we're on the don't path, which sets next. Otherwise, we're on the do path, so we set next to true, and we go check for open. Right, so next we check for an N. So we're just going to skip ahead of it, and we're keeping track of the fact that we skipped ahead. So enable state N. And you just say if char equals N, which at this point we know for certain is a fucking guaranteed thing because we're only ever in this state if we've already checked that, but repeatability, consistency, else enable state dot reset. Okay, so we say enabled state equals enabled state, it's comma, right? Don't comma. Okay, and we're just going to copy this from here. Next is going to be T, if this is a comma. Ooh, that's a nasty little escape character case there. So you're a comma. Okay, and then, and yes, I know it's apostrophe, not a comma. Oh. Sadly, I'm actually nowhere near the Gold Coast. Though my extended family's over there. So much so that I'm gonna have all Christmas to stream because my family that's going away to visit the extended family on the Gold Coast for Christmas. So yeah, but I mean, I might hit you up next time I go over there, but it's probably not going to be for a long time. I don't really like traveling, especially not in Australia. It's fucking expensive. Yeah, I might be interesting just to do it, but who knows? It's kind of like the thing of like I worked like so much, and then like our work closes for like the 2 weeks of Christmas, so it's like I kind of like don't want to waste my time time off going over east, but I might, because if I got somewhere to actually do over there rather than just being like I'm going on holidays for the sake of going on holidays. So T needs to look for open. Okay, let's find the T. We set to open, and again, open looks for no, open. Open looks for you, and then close. Close looks for you. Okay, so except you set close, and I'm fairly sure, and then you set done, and then done does the same thing. Done should scream at you. You scream unreachable. You scream unreachable because you should never be able to get to done. Okay, so then down here we're gonna spawn you. I'm gonna say format you, and you're gonna be true, and then I guess true. Technically, I could set it to false, false. And I have a special case for it. Anyway, path, and then also if path and also enabled. That's probably spelled very wrong. But we're going to say path and enabled. Else if pass, and then else. So then you go here and we say color sRGB, and then we say 0 0 1. Heyo, 001. All right. That might work now. I have no idea. So we're setting them blue. Where to double check if it's enabled, we and state is done. Right. and then we need to call state.reset, enable state.reset. Because we don't want it to accidentally reach out unreachable bits of code. So just want to do it. So only if it's enabled do we add the numbers to our multiplication, and then we do that. So that should work. And then if it's not enabled, we still add it to the list, but we set it to false. See, set it false. You know, technically speaking, I think better code would be to put the word enabled here, because then we're showing that that's actually what that's recording instead of true and false. And it shouldn't make any difference to the compiler because it's literally just loading a different value. Might be faster, might be slower. I don't know. I don't know if loading a constant is faster or slower than loading a reference, but oh, something crashed. It reached unreachable code. Yep. Which piece of unreachable code did you get to? How did you get to the fucking stage done though? That's significantly more confusing. Because I didn't change. Oh, because I'm not resetting. That's okay. Okay. If state's done, if it's enabled, so that should indicatively indicate that that else goes to there. And then I think this goes here. Right, that should fix that. And then the reset happens regardless of which list we add it to. So and that means I can actually move this out here. We can say, okay, add it to the list with enabled set. If it's enabled, add it to the total and then reset. See, that's why we make little bits of code unreachable, because then it crashes. Okay, do that. Okay, so 1 works, 2 works. Now 2. We're looking for a word that says, hey, look, don't. Okay, so I would kind of like to highlight the don'ts and the do's. That said don't, and it's blue. We're looking for when it turns green again. It says do. Hey, look. They would be good to highlight those. But the issue is to highlight those. Anyway, let's copy this value across and see if this is actually correct, or whether we need to be tweaking the code before I go messing around too much. Trying to... Hey, you got a star. Okay, return to the event calendar. Okay. Is this looks like a camel. The Christmas tree. Well, the big number 10. Anyway, so what we're doing, so we're trying to work out how would I well, I guess the easiest thing to do would be to and this is what I was like, there technically is a case that is impossible to reach, at which point we can use that as a custom color and therefore set the value. So the case of false true, false is not possible to reach. So true means it was a correct word and it was enabled, whereas you can't be a correct word and not be enabled. Like, you can't be an incorrect word and be enabled. Like, that's not a valid thing. Like, up here, we literally push the word false. Oh, and then enabled. No, we want to say, I guess, true? I guess we can say false. It's false. It's neither. All right. So if the word happens here, and then you... It's interesting. This could really... Oh no, because this should only trigger. So if you're in state D, if the character is D, so that was the if side effect. Yeah, so in here, when we set it to O, we can say send the pulse of true, false true. So false as in you're not an accepted word, but true because you're enabled, which is kind of backwards. No, well, yeah, okay, never mind. Like, the orientation of this is not necessary to decipher. And then technically down here we should match, but anyway, we'll do that in a second. Yeah, I'm just trying to make sure that in my head. So up here, if we find the letter M, we've started a new word, push the current word up, right? Which means that it shouldn't be possible to then find a word D while we're in the middle of finding the word mull, which means that technically this shouldn't cause weird clipping of words, because it only pushes the word when it potentially finds itself. So because all the words are compacted together, it may split interesting things like a D followed by an M, but they're not all on their own line. We're just breaking up chunks. So it's like if it has an M in it, we will color it that color if it ends up spelling out mull. But like do and don't contain an M, so it can't split a do and don't apart partway through. So that should work fine. And then when we come down here, and then when we color it, we're gonna, instead of doing this weird bullshittery, we're gonna say match, and then we match pass and enable, right? And then we say if it's true, true, comma true, do this, and then we say color sRGB. So true is 0, 1, 0. Right. So if they're both enabled, then we do that, and then we say if it's true. So the word is enabled, and then false. Well, the word is accepted, but it is not enabled. Then it is color sRGB. This is the blue. So 0, 0, 1. So blue if it's disabled. Then we want to go false, true. False, true. What the hell was false, true? Color, false, true. Okay, so you push the word. Is state done? Okay, no, it's you're up here. If it says a D, so false, true is a word that is do or don't. So sRGB. So that means that you would probably want to be like purple. So I think that's 1, 0, 1, which actually means there's a weird pattern here of if this is true. Not really. If this controls the blue bit, no, not really. Okay, never mind. Don't mind me. So if it says false, false. If I can spell it, fuck me. Color sRGB, and then so this would just be red. I guess technically, the red bit is the bit that's being controlled. So the red bit is controlled by this byte, by this bool, and then this bool does whatever the fuck it wants with the other bit, because it's 0, 1, 0, 0, 0, 1, 0, 1, 0, 0. Okay. Anyway, that should mean that when we run it, the do's and the don'ts should be like purple, perhaps. I think it's purple. So keep going until, no, then we click day 1. We're going to click day 2. Okay, that's coloring the wrong things purple. That's interesting. Because I'm fairly certain that I said false, false. And up here, you're pushing false, false when the word is M. You're pushing false, true if it starts with the letter D. Oh god, they're all overlapped. What have I done? I don't think I'm fucking... Am I not resource scoping you? I am state scoping you, so I don't know what the hell is going on there. No, we go back here. Oh, this needs to be state scoped to the fucking... Yes. Okay, so why the hell are you ending up all purple? Mostly because... Oh, God. Do triggers a hell of a lot more than anything else, I think, is what's ending up happening there. It's starting to chug. I think I'm running something far too... Like, something's running every frame when it's not supposed to. Anyway, these also need to be... You need to be state scoped to... It's puzzle state 2, and then the other one needs to be state scope to puzzle scope. This is puzzle 1, so that they don't end up overlapping. Your state scope to puzzle 1. Okay, puzzle 1. Okay. Interesting. So what's ending up happening here is that the do's trigger far too much. Wait, no, you should be pushing false, false. I don't care about you. It's here. It's goddamn fucking here. We go. Oh. Was it? It was false. False true. It's here that I'm gonna push. Weird. Because it's only when we find a do or a don't. That's what the issue was, is we were turning it purple whenever we failed to find one, which is probably every letter. And that was probably why it was starting to run really slow, is because it's every like letter was not an M or a D, and so it was putting it in that place. Because the D resets more frequently. I don't know. It's still wrong. The thing is, when it turns blue, we're looking for a different colored letter. Hello. Mole. They're all green. Do. Okay, so first off, did I click on the right day? What the hell happened? You are putting out the right value, I think. The fuck? So, first off, what am I doing wrong? So if enabled state done, push the word with false true. False true, which is like that magenta color. Right. But we're resetting it, so I don't know how all of the fucking... So it's false, false, and then it must be up here. We're putting false, false. So... You said it's false, false. You said it's false, false. If you're enabled, you push the same word as false true, and then you set true, and then toggleable. So then we match pass and enabled. Oh, no, it's not enabled. Well, it is, but it's the wrong fucking enabled. The issue with fucking typos. Okay, that should fix it, because we were basically just going to whatever the default value was last. And hence, all of the characters, even after they were enabled and disabled, were incorrectly done. So, it says oo, and oat, and oo. Why is the D not working? God damn it! So fucking close. It's not like they've got an M trailing them, so am I just putting that thing in the wrong spot? I thought I spend more time trying to make a nice visual than I spend actually doing it. So if char equals, if char equals D. No, it's else. It's in the side effects. We want to push if it fails. Hence, you know, actually, I have no idea. Does that make it? All right, no, because when it succeeded with the D, it was clearing the word, and then when it succeeds to find the word do, it stores the word. So, oh god, that's chugging. Yeah, it's running real slow now. So it's not when it fails. What the hell is it then? It's not when it fails. If side effect M. If it succeeds. Oh, right. We should. So it is when it succeeds. Because otherwise, every time we always put the word. We need to add the word to the string after we've taken it, which is why the other one worked. Right. Hence, we were adding the D before we took it. Okay. I thought I knew this. Thought I had it. This should fix it. I get that bug right. Like I avoided it the first time because I intentionally put it after because I was like, that'll work. And it didn't work. So do, and now something's still going wrong. Oh no, because it says do, right? And it says don't. And then it says don't again. And it says don't again. And it says do. And then it says don't. And it says do. And it says do. And it says don't. Hey, oh, it's working. That's fun. Do, don't, do, don't do, don't do, don't do. Okay. So that's that one done. I don't remember what the next one was. Something about a shop? No, that's the one we're currently doing. So we go to Adventure Code and we go number 4. Oh yeah, an Xmas word search. So this one, I am almost certainly just going to brute force, but I do have a cool visualization plan for this one. So who knows how big the day 4 thing is? It's 140 lines, and I don't know how many characters is the issue. What is that? It's gonna have to like count it. Oh wait, so 140 lines. I'm not gonna manually count it. I'm gonna fucking use code to count it, but we're gonna have to count it to do the logic. So first off, we go here, we go here, we go here, we go. Okay, so we're gonna need to say that our it said word search. A word search is what we're doing. So we're doing a search. They're looking for the word Xmas in our data, which is literally just made up of M's, A's, X's, and S's. So it's literally no other letters but the letters for Xmas. Just sprinkled through here, and it says the Xmas can be spelt forward, backwards, and diagonally. Horizontally, vertically, diagonally, written backwards, and even overlapping with other words, which is not relevant because when overlapping is what makes this easy, which is, I'm a bit worried that it might decide that they can't overlap in the future. Like that might be part 2. But overlapping makes this easy because it means we can literally check if you are an X, check above you, check below you, check to your left, check to your right. Now, do they have an Xmas written diagonally backwards? Xmas. I want an Xmas written. Wait, what? Xmas. Xmas. There. Where the fuck is this M coming from? Oh wait, Xmas. I'm not seeing any diagonal backwards. This one, diagonal backwards. Okay, so literally it's going to be check all the cardinal directions. Just if you are an X, check the directions. So all we need to do is make up an array of arrays, which is going to be fun. So we're going to go, they really made this kind of easy. So we're going to be like enum. Right, so we need, first off, a resource, because we're still going to store it. So we're going to say, we need to count the data as well. So we need to go, I guess the setup, this is going to be the first time wait, does our setup run at the right time? Ooh, our setup may not run at the right time. So we may not be able, we may have to hard code this. So you are going to be this, and we're going to say asset server dot add, and then we're going to say let new image equals more cool Bevy API to use image new. Okay, size x extend width. Okay, our width is unknown at this point, so to do. Our height is 140, and our depth is 1. Okay, dimensions is dimensions. Right, what do you want? Texture dimension 2D. Okay, and then data is going to be just a vector. I guess it's something like, okay, do you take data as a vector? Yes, vect. Wait, no, it's vec, and then we need to say 0. What, I guess 255, comma, and then it's 140 times to do. Okay, let's make these const width, which is an I32, I don't know, equals to do, and then yeah, let's just make it equal 1 for now. 1, and then const height, which is an I32, and that equals 144. Not 144, 140. And then width. Okay, so you are equal to height. You do want it to be U32. Okay, U32. U32. Okay. 1. Why are you not accepting 1? Oh, array depth. Yep. I'm supposed to put the name. Yep, the array. 1. Okay. So then we want this, and we want to say width times height times 4. Okay, and then format is texture, Bevy texture format. So we want it's like sRGB. We'll just go with any old one, and then we're gonna say you're actually sRGB. It's okay, red, blue, green, alpha channels, 8-bit integers per channel. The color is converted to and from linear color floats 0 to 1 in shader. I believe it's this one. And then asset usage is just render asset usage. Okay, so we need to keep track of the image handle. So we need a resource for that. So we need to be derive resource. You need to be a struct image handle. Right, and we handle to an image, like so. Yes, very obvious. So we're going to say let handle equal. Well, I guess you need access to just image handle. Handle. So you're gonna be raw. Got image, I guess. Maybe, I don't know. And then you're equal to the asset server dot add. I guess technically we don't need to do a let or anything. We can say image dot 0 equals asset server dot add raw image. Right, which should just give us a white image, and then we say you are just image dot 0 dot clone, like so. Hey, okay. So outside of the fact that you were going to crash because you've got to do written there, it's your width. Okay, so that should make us a white image, and then we need an enum. This is going to be our parser. So chars, I guess. This is going to be xmas. Okay. So first off, let's double check that our image is fucking working. Oh, because you want to be as you size. As you size. Thank you. Right. raw image doesn't need to be mutable at this point, does it? Don't have insert turned on. So raw image, we generate the raw image, we insert it. So when we need to also dot init insert resource. Ooh. Can I just say image handle default? Oh. Okay, so what is your bitching complaint? Because you need to be res mute to an image handle. Like so. Okay, so we have image and image handle, width and height. Okay, so when I insert resource, question, when we go to day 4, do we get a white square? That's always fun with Bevy. Yeah, never fucking know. We didn't get a white square. Did it spawn a image at all? It's called monitor. Why are there 2 monitors? Okay, because they're not related to what I'm doing. Node. Oh, because I don't think we changed the day, did we? This is day 4. Okay, that should fix that. Quiz close. Okay, now day 4 should actually do something when we click day 4. Day 4. Okay, got a big white square. We should probably give it a custom size. Let's go to day 3. Let's go up to the piece of code that spawns the monitor in. And go, the monitor was a good size. I think that was splat 1000. Up here. Who spawned this? It's custom size splat 1000, please. Wait a second. That should already be what it's doing. Cool. It is splat. Okay, so we're gonna need to like splat like 800. Anyway. So then if I go into here and I go, hey, can I find this is it you? Entity? Sprite? 800, please. Oh. This is where the edit is really useful because I don't have to recompile everything to check. Like, hey, 800, please. 800 is still way too big. 700? 700. Okay, 700 by 700 it is. We should also make it like gray. Gray, please. Okay, maybe even 650. So can we go day 4, flat, 650. Now to make the image gray, we kind of need to be like maybe something like 165. Just not 100%. It's gonna also make it slightly transparent, but we can worry about that later. All right, so parsing day 1. So first up, we're gonna let the table equal. Okay, so let mute table. The table is going to equal a vector new. Okay, I'm gonna say let mute. Is this a single row? I think this is a row. Oops. New. Okay, so we got a table, we got a row, then we're gonna say for line in data.0.0.lines. All right, so I'm gonna iterate through all the lines, and we're gonna say for char in okay, it's right. First off, we probably just want to print a little bit out so we can fix the table thing, that issue. What was it? Where the fuck? How did I end up at? Okay, so in line charts. All right, so we need to say match char, right? And then if the char is X, we're going to say row dot push char x. This is very, very inefficient. And then we're going to say I'm really curious if it has unreachable shit, so I'm going to just literally say unreachable and see if there is somewhere hidden in there not a character, like not x, y, not x, m, a, or s. Because I've looked at that chart and it does, nothing jumped out to me. So x, m, a, and s. Okay, now question, are they capitalized? They are in fact capitalized. X, m, a, and s, like so. And then at the end here, we go here and we go, okay, once you finish that, we need to say table.push line, row. Okay, std mem take row. Thank you. So chuck the row in there. Now we have a table, which is a variable value. And then what we can do is we can also, when we get to here, just say, please print line that is table dot first dot unwrap dot length. Please tell me the length of each one so I can fill that into my thing and generate the right sized document. I'm hard coding it because I don't think it's worth making it dynamic. I suspect that it is like they're obviously generating it. We've got to click one, don't we? One. That'll run the code. Okay. Yeah, 140 by 140. So it's almost certainly always square, which is okay, cool. So, like, I can't imagine that that's part of the advent is working out what size the data is. That seems cruel and unusual. Okay. So, what we need to do is we need to go chars. We need to go impl chars, and then we need to say fn. It also didn't crash, which means that there's nothing but x's, m's, a's, and s's in there. So do we want to say search? Right. X I32 and y, which is also I32. We could also just say search returns this, which is a tuple of I32. I32. I think it should be I size. Doesn't really matter. Again, just weird like brain optimizing shit. Right, like nice code. By 8. Each one should have 8 neighbors. Right, and then we're gonna say we just need to come up with the 8 neighbors, which is going to be -1, -1, and then it's 0, -1, and then it's 0, but no, it's 1, -1, which is searching down to the right first, but anyway. We need to do that, and then we need to go, hey, you don't exist. You just fill the space bars to make everything look nice and neat. Now, there is something I can do, but I don't remember how to do it. It's like a format, ignore format. No. Someone who knows how to use Clippy, tell me how I make it not format this when I save. I don't want you to format this, please. Is it Clippy? I saw something the other day. I was messing around in someone else's crate, and that's in like Clippy ignore format or something. Rust ignore format. What are they called? Like attribute. Haha. Okay, cool. Found it. So now it won't reformat this, and it's really obvious that it's... So first off, you're not -1. You would be... Yeah, no, you're 1 up and you're 1 to the right. So you're -1, and then you're 1 up, so you're 0, -1. Then you're 2 there, which makes you -1, 0. And then you are 1, 0. Right, like so. And then you'd become 1, 1, and 1. Okay, so that's our search area. And so we're going to go 4x in 0. Yeah, I guess 0 and then 0 dot width for y in 0 dot width. Okay, so we're going to say let start, or let current equal table. So the tables, we're going lines at a time. So the first, each vector, into the vector is the x and the row is the y. Okay. Again, because it's allowed to overlap, it doesn't fucking matter. Now, I'm confused why it thinks it's an output. Why are you thinking it's an output? Why can you not? Oh, because you can't index as users. Also, it's not supposed to be width, it's supposed to be height. It doesn't matter because they're the same, but in theory, if it changes, we would want to know that. Okay, you are clone and copy. Derive. Debug. Clone, copy, equal, par equal. Thank you. Okay, so we get our current and we say if current does not equal char x, we want to continue. Now, I feel like you're supposed to be calling like a recursive function here, but I'm just going to do it as a sequence of fucking loops. So we're going to say, okay, we're going to say like let found found equals number. I'm also going to say let new green. We also need to get the image. That's what we need to do. So we need to go like, we're showing off how to use Bevy's new API for modifying images. We also need images, and our specific image is image. Our image is res image handle. Now we should know at this point that image handle is valid, so we're going to say let new image equals images dot get image dot 0 dot unwrap. Okay, we need to get mute. So now we have access to the actual image itself. Dot ID. Like that. Right. So we have our image, we have our found, we have a, okay. So I'm also going to say let new search equals, I'm going to say we needed like a Boolean value, I guess. I don't know. So I guess depth equals 0. I'm only going to be using the depth for coloring things. Like if I called a proper recursive function, I would have to like I could actually do that. But anyway, so if the char is not x, return. So otherwise, okay. So otherwise, we want to do other stuff here. To do check deeper. All right. First thing you are going to do is you're going to set. Why are you yelling? It's telling me that I'm indexing into a table. Okay, I don't care. So depth is going to equal 0 because we haven't checked anything. So then to do, and we go to deeper, and then we're going to say, I think the maximum depth is 4. So we're going to say, if depth is greater than okay. Maybe. No. Just okay, if depth is greater than 0. Wait, okay, if depth equals 0 means it didn't find a valid thing. So if your character is not x, so I don't want to set things weirdly. Okay, so we're going to say image dot get color at x and y. Okay, fuck you. We'll use it like this then, because I would rather just pass x and y in. Okay. Sadly, we need to know what x and y is, so we can't just index into the table. Thank you. So image dot get color x and y. So let c equal. Okay. Dot unwrap. And I hope that it's always right. And then we're going to say if c dot alpha is less than. Okay. Why don't we set it to black? So we're going to make all the values 0. So start 0 and transparent. So if the value is equal to 0, if alpha, which is alpha a float, okay. If alpha is equal to 0, then image dot set color x, y, and then we're going to say color. I'm going to make some consts so I can tweak this later. So we're going to say const color false color. And so the false color is going to be that's also color for one thing. It's going to equal color srgb. That's a const function. Cool. And you know, so it's going to be red. So if you don't find any color whatsoever, set it to red. Okay. It could just be that red's too bright. That's why I'm doing it this way. So false color. Why do you have an error result? Okay. I'm just going to say let underscore equal. Okay. So if it's not x and its alpha is set to 0, it means it hasn't been checked yet that its color to false. Next, if the depth equals 0, well, we need to probably get the color immediately because we don't care what's happening. Okay, and then if c is okay, so if depth is equal to 0, and current dot alpha no, fucking c dot alpha equals to 0, right? Then we want to set color. I guess technically we want to go I don't know. false color. Because it means that we checked and it literally found nothing. So what do we got? So we're checking if the depth is 0 and the alpha is 0, which basically means the color hasn't been set yet. Because it kind of want it to be like... Can I set the alpha for these? I can't. So alpha is... Okay, so it's possible for me to actually like manually set the alpha. So what we're going to do is we're going to say... progressively more green. I don't know. Const pass underscore 1 color. Okay, maybe we'll just... For now, we're just going to go pass. Okay, this is just pass color. And that's just going to be sRGB. Okay, so fail needs to not set the... So you need to set the alpha to just not be equal to 1. So like, can we say like 0.9? 95 maybe? Because I don't want a rounding error to cause it. So you are just going to be green. Right. So green if it succeeds, red if it fails. I was kind of thinking it'd be kind of cool to have like different shades depending on like how much it succeeded by, just so you don't end up with a bunch of fucking weird red green shit. But anyway, what the fuck do you mean? Okay, so we want color. No. Right. That's what we got. Okay, so we're just going to make it not quite 1, and then we're going to say if color equals to 0, set this to red. Does not equal 1. Well, no, because you can never check an X again. So it's literally like the X is if it equals 0. Because X can only set it to... Okay, so then next we're going to go through each of the fucking... So for for nx and y in current, well, I guess it's just chars dot search. So for x and y, and then so this is our step 1, right? And then we're going to say let depth depth equal 1. And then we need to check again. Okay, so I guess technically it's if current does not equal... okay, so we need to say let current equal, but it's x plus nx. Okay, we need to let x equal x plus nx, as he says. Alright, and then y needs to be the same, and y. Alright. This should really be done with a recursive call, but anyway, y and x. So depth, and then we say current isites. Also, we need to now, because we're no longer sure if these exist, we need to go get. So table dot. Okay, So let row equal table dot get y. Let some row to get the row, else continue because it's outside of the range, and then let current, let some current equal let's use those. Okay, let some current equal table dot get, I don't know, row dot get row dot get x, right? So get x, else continue. Okay, so now we have our current, and then we say if current use this. So if current does not, if current does not currently equal, what are we in? X m, so m, yep, m. If alpha equals to 0, it's more like we gotta say depth. I guess don't have to set the color at all, do we? We set the color if it's not equal to x, because if it's not equal to x, we're continuing. Wait a second. No. If it's not equal to x, we need to continue. We need to break early, basically. Then I gotta get it out of here. So it's not equal to x and its color hasn't been set yet. Set it to false. If depth is equal to 0 and alpha is equal to 0, so your color hasn't been set yet, set you to false. I guess technically it's, we can just say yes. I was gonna do a whole thing about, like, again, different colors, but we're just gonna say found depth or Xmas. Yeah, true. Let's just say depth. So we're gonna say the depth just says true. So first thing you do is you set depth to true. I guess we should do that after because we don't really care. So true, and then we say if depth, set the color. So if it was successful, we set the color because it means you found it, and I don't care. Like, I was trying not to override other colors, but it's like if we're gonna, it's either you found one or you didn't find one. So if you found one, set it to true. Otherwise, it's set to false by something up here. So we set if our, yeah, okay. I mean, no, because I was going to think we could set it to false, but it's like, okay, we need to get color. We need to go, hey, if get color, and then if alpha, set it red. So if the color hasn't been set, set it red. Then if it's not equal to x, continue. And then we say depth is equal to true, right? Which is just a way of saying we should probably do here. So depth is equal to true. And then we go, okay, if you're not x, return, because it's not you. Okay, then we don't want to do this here, I don't think. So after we've checked the next thing, it's if you want it equal to m, continue. Like, that's how the pattern works. So basically, depths, don't set depth. Just keep going down. We set depth true here, then we continue diving deeper. And then we say at the end, if depth. All right, so don't touch depth. So dive deeper and then set color XY false. Wait, these need to be as U32. U32. Right. So basically we dive a depth deeper, and so this is our recurring pattern here. So if we take all of this, we copy this and we go paste it here. So we can stop doing that because that's only done for that particular iteration. So this is depth 2. Yep. 1. Right. So we need to check U against A. Right. And then we're going to paste U one more time. But then you're the fancy one because you're the bottom one. So we don't need to check your neighbors, because if you are not a S, right. And so we say depth equals true because we've found you. And then we don't actually have to check depth here because you're the bottom. So if we get to here, then we are certain that we've found an Xmas. Wait, this is false color. We need true color, please. Success color? What the fuck did I call it? Pass color. Pass color. Okay. So again, if trap true, true, true. They all set the pass color. So let's make sure we've got this right. So this is depth 3. So first thing we do is we come in here and we say, hey, get me my current value. Right. And then get me the color of that current value. And you say, if the current value has not had its color set its color to false. Then set depth to true. Okay, so depth starts as false then. Because, okay, so depth starts as false. And we say, I hate you. So if you're not currently an X, check the next thing, because we don't care about searching if you're not an X. If you are an X, check all your neighbors. Each of those neighbors, get its row, then get its column. If it's not an M, continue. So we don't care if you're not an M. Then check all of its neighbors. Do the same thing. If it's not an A, continue. Check all of those neighbors. If it doesn't end in an S, we bail out. If it does end in an S, depth is true. We've found an Xmas. True. And then we say, set the color X, Y to the passing color. And because depth is true, when we now leave this, wait a second, that's not correct. Because we're searching like zigzags as well. All right, we'll work on that in a second, because that's where search kind of should come in. We need to make search bigger, and we just need to search all of search. Like search should just return a bigger chunk, I guess. Okay, so that's not going to work, because as I just said, we're searching zigzags, because we search like all of the diagonals and then all the diagonals. So that won't work. But the idea was then it would like trickle that back down. But anyway, what we can do instead is go for each thing, hey, if current is an X, then if current is an X, continue. Then we say for, so it'd be like X1, Y1. So it's going to be something more like this, comma. How do I algorithmically generate that? That's the fucking... So what we need to do is maybe go like enum direction. So you have northwest, northeast, east, southeast, south, southwest, west. There should be 6 of these. 7. Okay, yeah, 8. There's 8 of those. That's right. So then we're going to go impl direction. And then we're going to say fn step. And then so we're going to say you just return an I32, like so. And then we just say okay, so it needs to take it itself. So we need to match self. It's not quite as easy as I thought it was going to be. Anyway, so if we're stepping northwest, we are stepping negative -1, right? Or we're going north, so 1 on the y. All right. And then north is 0, 1. Northeast is 1, 1. East is just 1, 0. Southeast is 1, -1. South is 0, -1. Southwest is -1, -1. Okay, and west is just -1, 0. Right? I think that's all of them. -1, 0. Yep. Okay, so with that, we have our directions, we have our steps. So then we're going to say, so I guess for direction. So we're going to say direction, we're going to go use our strum magic that I've used in other crates. Oh, we've already got strum in here. So it must have been this that I was using strum in the other day. We need to derive from macros enum iter. Okay, then you can call iter, which I believe we need to. Oh, okay. So we have our direction, and then we're gonna go. Okay, so let cx mute cx equals cx equals x, let mute cy equals y, and then we're going to say direction. Okay, so for each direction, we're going to say let 1 equal, I guess it's let step equal, so step x, step y equals direction. That's step. Right. It's how much to step, and then 1 is going to equal so 1x equals cx plus x, no, plus step x. Okay. Okay. So it's not that. So we need to say like x plus step x. Now. Okay. As I32. Okay. So then we say 1y, which is y plus step y. Okay. So that's our x and y of our first one. And then I guess for speed reasons, it's been like a reason to return the code early. We're going to say at row, row, let sum row equals table dot get, because again we need to take into consideration 1y, that it's possible else continue. It's possible to fail this. So we also need to say like this, and then as u size. So it's possible for this to reach outside of the map. That's why I need to return like, so let's sum 1 equals table equals row dot get 1x, so get the 1, okay, and then we need to say copy all of this and then paste. So we need 2 copies, so you are 1, and then so you would be step times 2 times 2. So maybe we should change this to next x, and then next underscore y. So your times 2, and then you would be 2, and then you would also be your next next underscore x and next underscore y, and then you would be 3. Okay, so let's say if one, oh, I guess we just return early. Again, we don't need to check everything every time. So if 1 does not equal chars m, and continue. Okay, and then if 2 does not equal a new, and then if 3 does not equal s, continue. All right, otherwise we say we need to settle those as well, kind of a, so this shouldn't be next, this should be 2. We need to dereference 1, 2, and 3, because annoyingly. Okay, so if you get to here, then we know it's true. So we want to say let underscore equal image dot set color at so this will be 1x 1y, and then the color is passing color. We also want to set the color at 2 oh, brain, use the right letters. 2, and then 3 and 3. So we set all the colors to passing. Okay, so so as u32, as u32, as u32, as u32, as u32. Right, does that work now? Okay, so set up the colors there, and then we need to say bound plus equals 1. So we try each direction, and then in each direction we check the next 3 places. And then we never use depth because apparently we just don't care. Now, we don't need to make you mutable because we have a mutable reference apparently, and then we're going to print out bound. Print line, copy to advent. And then found. Okay, so if I run this should work, because we're literally just basically going, hey, check all 8 directions around this thing, step 3 steps in each direction, and check to see if they're the right letters. As you go, apparently it's all red and you found 0, so that's not correct. Now, to work out what's gone wrong, are you returning early? Are you actually not? So it got to here and it says copy to advent, and it's also got that weird capitalization, so that it's definitely making it to here. Okay, so current, it didn't crash at any point, so that's interesting. Okay, so we're gonna say, we get to here, we're gonna say char is x. We're gonna run this and we're gonna go, these should just print out just fucking lots and lots, char is x. Because there's lots of x's. So unless it's just not loading the data correctly, which is entirely a possibility. That's the wrong day. Okay, so yeah, it spat out a lot of char is x, like thousands of them. Okay, so it's definitely getting to there. It's apparently just never setting the value. Okay, so first off, I guess to check in here and go, hey, are we getting to here? Oh no, I just released it. Ah, no. That's gonna be real slow to compile if I do that. We don't need that speed. Okay. No, it's gonna print it like 6 times as much, but like, is it actually doing it? No, so that, well, that or it's chugging along. Wait, no, we never clicked on the day. Okay, so it's printing char is x a lot. So char is m. Okay. Char is a. And then finally char is s. Now, what I can expect is that we'll never find char as s, because char as s implies we've succeeded. So it should never say char as s. We have to click on the day. 1. Okay, so the final one finished on char is m. Yeah, which would be that m. Is s. So it doesn't appear to have a single instance of char as s, which implies that it's never once finding the word Xmas. First off. So it definitely does actually exist. Now, what it could be is that I'm just doing that wrong. So let's close this. Go. Yeah, go. Did I fuck it up? Maybe I'm just not looking for the right letter. Well, it can't be that, because otherwise it would have crashed here. Xmas. Okay, so let's get rid of the M. Get rid of the A. You know what it could be? That's exactly what it is. Times 3. 3. Because we're checking the same letter twice, it's impossible for it to both be an A and an S, which is why it's never finding one. Did I remove all of the code prints? No, I didn't. I don't need you printing any code, please. Okay, so then when I click here, I click 1. Hey, look! Heyo. Yeah, now it's just printing charts. So apparently the answer is 2618. So let's copy that over to Adventure code and see if it's correct. And then I want to see if I can implement different colors. I'm just going to make sure the code's actually working. Yay. Okay, continue part 2. So to add different colors. To add different colors, what we're going to do is instead set each of the passing grades based on the I can set it based on the letter it is, but we only want to set it if it passed a certain distance. It's kind of like we want to set all previous of the letters. So we kind of want to get the color of the specific character. And we're going to say, so we probably want to take this approach. Okay, so we want to say, so we want to UB pass 1, right? And you'll pass 2, and UB pass 3. Okay, so and then passing 4 would be the passing all. Okay, so then we want to go, you'll pass 1, you'll pass 2, and you'll pass 3. Oops. 3. Okay, so your color is going to be, I guess 80%, 80%, 85%, 90%. Okay, and then you're 100%. So we could make it slightly higher if we need to. But anyway, so we're going to say you're not red. You're going to be like, well, could set its passing value based on the specific value, like setting it as it sets further, it sets different values. Because then it won't necessarily overwrite, and it would actually be a more interesting result, because it means if it's like connected to more than one but not quite one. All right, so maybe we'll do that instead. So instead we're going to say, hey, if you get to here, if you're, I'm going to say only if it's an M. So if it's only an X, we don't care. But if it gets to M, we're going to say, so I'm going to say, let color equal get image dot get no, wait, yeah, so we're going to say get xy, and we're going to say if let okay color equals image get xy, and we say color dot red dot srgb, let color equal color dot srgb, color dot red equals made it past the first one. I guess we're going to say your red is equal to 0. Right, and then we're going to say color dot image dot set color at xy to color, like that. So set the whatever color you are, just set its red value to 0. to color. YouTube. Yeah. Yeah. And then we say like let. Okay, so we take this and then we copy this again, but we go instead of x and y, you are 1 underscore x and 1 underscore y. Same again. As you did. Okay, except yeah, I don't know, you also read. All right, so then we're gonna do like the concept of copy this, paste it here, but we're gonna say green equals 1. Green equals 1. And then you're exactly the same. You're exactly the same. So then you copy and you go here and you become 2. 2. Okay, and then we're gonna say copy all of this again, and then we go hit here, do this. We need to copy one more time, paste you here and say 2, no, it's 3, isn't it? 3x. Y, X, and Y. And you're blue. Okay. I don't know what it's going to look like, but that basically will go through and it says if you've got exactly one, like if you get one letter in, turn the red off. If you don't have any connections, you're red. If you have one connection, the red is off. If you have 2 connections anywhere, the green is on. If you've got 3 connections anywhere, the blue is on. Hey, now we have a really, really hideous looking color map. Okay, so to be honest, it probably looked better as the white and green, red and green. I think the red and green definitely look better. Yeah, it was a colossal waste of time. It's fucking just looks better as white and green. It's just too garish looking like that. All right. Did that fix it? I think that's all the code that I changed. We should be committing this stuff to GitHub. Okay, yeah. It'll be all like day. Oh, we have to finish the fucking 3 and day. 4. Okay, go to 4, go 1, go. Okay. It's just less hideous to look at going like this is all the Xmas's. Kind of nice. It's still painful in the eyes, but better than it was. Okay. So let's finish part 2 of day 4 and we'll commit that to GitHub and then we'll continue on, I think. Maybe, I don't know, how long has this stream been going? 2.5 hours. Yeah, we'll see. We'll look at the next day and see what it is. Okay, so part 2. They look for the. You flip over the word search to find that there isn't actually an Xmas puzzle. It's an X-mas puzzle, which is you're supposed to find the 2 MAS in the shape of an X. One way to achieve this is like this: MAS, MAS. Okay. Irrelevant characters have been ignored, replaced with dots in the above diagram. Within the X, each MAS can be written forwards or backwards. Okay. Well, it kind of implies that the A is always the center. Okay, cool. Here's a sample from before, but this time all the Xmas's have been kept instead. Okay. A, M, S, S, M. Okay, in this example, the Xmas appears 9 times. Flip the word search from the instructions back over to the word search side and try again. How many Xmas's appear? Okay. So this shouldn't be too hard. Mostly because all it does is use the same code that I wrote before. I say that every time, but like then I end up changing it so drastically it's not really the same code. So we're just gonna again copy paste this. So what we need to check instead of right, you need access to the fucking image. Like so. We also never spawn anything with commands. You don't actually need commands. Okay, so that should make this code work. Okay, so next we need to say, like, if I said fn x, right, it's going to be exactly the same code but checking slightly further abroad. It's actually like one of the more boring expansions on the thing, because literally it's probably also partly because of how I've done it. Like if I was writing some kind of recursive code, it'd be interesting to modify, but like wait, I don't even need to do that. I could just const x pattern. This is a thing of I32 I32 by by what there's 4 and it's in the shape, but that, technically it's 2 sets of 2. It's more like you are a 2 like that. Why is it like that? Because you'll see in a second that when I do this, and I go here, and then we go here, and we go, okay. So we need to search up, -1, 1, and then we need to go down, which is 1. Down, which is 1, -1, right? And then we need to search down to the right, which is -1, -1, and we need to search up, which is 1, and 1, 1, 1. So the reason it's like this is that we can't have check all 4 and check if this. We need to check if to the left is an M or an S, and then check down and go, is that also the complement? And then we need to check, so we need to go we need to hit you and be like fm comp, which is going to take which is a self and other, which is a reference to a self, and then we return a boolean. We say match self. Okay, so if you're an X, you return false, because X's don't have a complement, and if you're an A, you return false, because A's don't have a complement. And then we say if you're an M, you return with the other equals equals char s, and then s is returned whether the other is a char m. Okay. So then in our really boring piece of code, what we're going to do is we're going to go, not even for direction each. Get the letter. Let's see. Yep. Okay. Image and false. Yeah. Okay. So if the char is not an A, continue, because A is what we're looking for. So if it is an A, we need to go. We need to show. It's not even really worth doing the for loop. Just kind of want to go like, let 1 equal okay, let's let row some row equals table dot get x plus x pattern. Guess it's 0 0 as size else continue. Okay, and then we need to go, this is 1, which is again get this, but we want to go 1. Okay. Thank you. As I32. As I32. Except I think you're Y, aren't you? Y and the second value. And your X, first value. Okay. Wait. I'm indexing into the array. How's that working? I'm indexing into two arrays. Okay. No, so it's 0 0 on both of them. It's then this just dot 1 and dot 0. Is that how that works? Okay. So we have a row, except you are row. Okay, then we have our char. So that's 1, and then we need to go, hey, can you get 2? So 2 would be the other one of you. So you, and you, so you're 2. Okay. And then we may as well just grab out the others as well. So you would be 3, and you are 4. Okay, so 3 is 1, 1, and you're 1, 1, 1, 1. Okay, so that should get all the correct letters and numbers out. So what we need to check is okay, so going here, it's not even going to bother returning early or anything. I'm going to say if 1 that is comp and 2 dot comp 1 and 3 comp is comp and 4 dot comp 3, then bound plus equals 1, and then we need to set that fucking monstrosity. Okay. Let's It's a real monstrosity, isn't it? And we say, I guess here we say for something like x, y in x pattern. X X X X X X Y. Hello. This is very boring. Y next Y. So then we say, okay. So first off, we need to say image dot set color at XY to pass color. Right. And then we need to go here. We need to go hello, yes. Can you set the color at X plus as I32 plus XX as U32. Okay. And then your Y would be the same thing, but I'm not copying that horrendous mess again. Oh, so we'll copy that, paste that. But you become Y's. Y and X, Y. I've made this needlessly complicated. And then you would become X plus YX and YY. Okay, so isComp. And then isComp is just another function that we can call saying char isComp, which just takes in self and returns a boolean matching self, and we say self a or self no, it's not a, I guess it's X. We say false, and then we say self M or self S true. Okay, so basically we check the two sets of crosses and we say, hey, if one end is either an M or an S and the other end is its complement, and then we check the other X too. Let's see if we can data. So we basically go, we grab 3x3 chunk with an A in the center. So a 3x3 chunk with an A in the center. So we go here, we go, hey, are you an M or an S? Yes. Is this your complement? No. So you would fail. But for this example, we can say yes. Then we go here and we go, hey, are you an M or an S? Yes. And then you go here and you go, you, it's complement. And that's all we're doing. It's really fucking simple. Yeah, oh god. I don't like the yellow fucking lines. Like so. Now we're setting the color to pass if it succeeds. We're going to set it to false if it fails. Found plus equals 1. So if it is a complement number and its complement is the other side, and then the other one if it's a complement number if it's a complement the other side. This should work. First try. You know, fingers crossed, hoping, praying. I say that it's not going to work, but it'll just make it not work. Or, and then we say solve puzzle 2. It doesn't look right because there's an X here, but there's no cross, which makes me think you've got the wrong number. We'll see. It might be the right number, but I suspect just looking at the image, which is part of like why data visualization is really important. There's a cross here, which doesn't make sense because that should be going out of bounds. There's 4 dots here. 4 dots here. Like these are. They should all be forming X's like this. So the fact that they're not concerns me. I suspect this is, yeah, it's not the right answer. Your answer is too high. So what are we doing wrong? So we are checking 0, 0, 0, 0, 0, 0, 1, 0, 1. Now, this is horrendous. Okay. 1. Okay. So our ordering is to check kind of want to just condense these into a fucking list. Okay, let's go with instead. You are just going to be 4. Now, we need to check and go, these are definitely opposite corners, correct? Which actually means we can come down here and we can simplify this fucking thing and go, hey, yeah, just, it's just x, 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 y. Yep, and then you can go to this entire one. Just go. Yep. All right, so now the issue becomes that we need to go pattern your y, your x, your y, your x, 0, 2, 0, 2, and then your 3 and your 3. Then we can double check that they're the correct patterns. If current equals A. All right. So, -1. -1, 1. Negative, let me go to 1, negative. Go to -1, -1. Okay. We go to +1, +1. All right, so they are the correct 4 corners. So where am I fucking up the corner reading code? Oh, well, that would help, wouldn't it? Fuck me. That would explain it. This is parse day 1 now, thank you. And this is parse day 2. Because I fucked up. And I wrote all it in parse fucking the wrong day. Don't worry about it. I just put all the fucking code in the wrong place. It's all good. It's all good. This shows I've been streaming for too long. I want to see if the day 5 is something that I think I can solve quickly. Otherwise, I'm going to call it a day. Day 2. Hey, now they all look like X's. And now there's only 2,000 of them instead of whatever number there was before, which is 2,600. So that's 600 less. Okay, we go here, go here, go. Hey, yeah. I know that number was way too high. Let's try it, not submitting the same number. Yay, we got it right. It did work first try. I just put it in the wrong place and didn't run the right code. Okay, oh god, day 5. Let's see what day 5 is. Okay, so the else must recognize. Is there waste no time explaining that the slave life safety manual updates won't print correctly. Failure to update the safety manuals would be dire indeed. So you offer services. Okay, safety protocol clearly indicates that new pages of the safety manual must be printed if this in a very specific order. The notion x, y means that if x it means that if both pages, page number x and page number y, are to be produced as part of an update, page x must be printed at the same point before, at some point before page y, number y. Okay, so the notion XY means that if both page number X and page number Y are to be produced as part of an update, page X must be printed at some point before page Y. The ELF has for you both page ordering rules and the pages to produce in each update. Your puzzle input. Oh god. Oh god, it's got a double passing section. Nah, it was gonna come up eventually. It's so much harder to pass input values when you have to wait for a specific change in the value. Anyway, you can't figure out whether each update has the pages in the right order. For example, lots of fucking numbers. The first section specifies the page order was 1 per line. The first rule means that if an update includes both page number 47 and page number 50, then page 47 must be printed at some point before 53. Okay, 47 doesn't necessarily need to be immediately before. Yeah, okay. Other pages are allowed to be printed between them. Okay, the second section specifies the page number of each update. Because most safety manuals are different, pages need to be updated at different updates are different too. The first update means that this update consists of the page numbers. Okay, so this is sequences of updates. Okay, so the page to get the prints going as soon as possible, start by identifying which updates are already in the right order. In the example above, the first update is in the right order. Okay, correct. So a second between must be before. Okay, so because the first update does not include some page numbers, the ordering rules involved in those missing page numbers are ignored. Okay, the second and third updates are also in the correct order according to the rules. Like the first update, they do not include every page number, so they aren't in ordering apply. Okay, for each within each update, the ordering rules that involve missing pages are not used. Okay, the fourth update is not in the correct order. It would print pages before 79, and then we said 79 has to come before 74. Okay. The fifth update is also not correct since the breaks rule. Okay. The last update is not correct due order to breaking several rules. Okay. For the I mean, I also need to know the middle page number for each update before printing. What? Okay. Because you are currently only printing the correctly ordered updates, you'll need to find the middle page of each correctly ordered update in the above example. The correctly ordered updates are these middle page numbers respectively. Adding these page numbers together gives us, of course, you'll need to be careful to actually list the actual list of page ordering rules is bigger and more complicated than the example above. Okay. Determine which updates are already in the correct order. What do you get if you add up the middle number of the correctly ordered updates? Fuck, that seems complicated. I feel like this one is going to be another one. I'm going to end up brute forcing my way through. We can just pass the rules and then pass the page ordering, and then iterate through the page ordering and see if literally any of the rules are broken. The hardest part about that is we'll need to like systematically check. So what you'd have to do is iterate through every rule. Ooh, you have to check both sides of the rule though, because in theory, yeah, you'd have to check both sides because 74 comes before 47. But if you're checking 47, no, because 74 has to be in the list somewhere. So theoretically, this rule can't be invalidated if 75 isn't in the list. So this rule will always get procced. So what I can do is I can check each rule and then go if you are the same, if you are the starting number, so this rule applies to you, check to see if previously the second part of this number has come up. So I don't know if we'll finish this one today because this feels like it's going to be a long slog to just sort of grind out because my brain is a bit asleep. So we have lots and lots and lots of page numbers. And then we just have to work out the middle pages of the acceptable ones. So we might make that its own list. But so all we need to do is go new. No, up here, please. New. This is going to be day 5 dot data. Okay. We need to commit this to GitHub before we go fucking. So don't include day 5. Commit. Okay. Paste. Okay. So we're going to just copy day 4, I guess. It's today 5. Then we need to go to main. We need to go somewhere. We go here. We go Euro 5. All right. And Euro 5. Okay. So puzzles. I think that's everything. And then we go here and we say you're at day 5, and then we go back to main and we go, okay, so we need a day 5 and day 5 plugin. Okay, so day 5. That's like this like slowly increasing list of shit that's not actually relevant. So I don't think width, height, or this map stuff is relevant at the moment. You need to load something in the background. Oh, I'll work on that later. Just, yeah, white square for now. Okay, so clear out day 2 parsing. Okay. Yep, you don't need that anymore. Same thing here. Just gonna clear this out. I think we need our directions anymore. Don't need our chars anymore because that's all unrelated stuff. So we need to copy you, paste you, and say data day 1. Data 1. Okay, and then. Okay, so I'm gonna not visualize anything because I just sleepy. Okay, so it's gonna we'll load a sprite, but we're not gonna actually load anything on the sprite. Like so. Okay. So all we need to do is parse it. So what we're gonna need is that new rules equals a vector. Right. So it's our rules, and then we're gonna say let new page updates. That's also going to equal a vector. Okay. Then we need to pass the data. So for line in line in data.0.lines. Okay. Then we're going to say if line dot contains a pipe symbol, then we're going to parse it as rules. Else we're going to pass it as an update. Okay, so else we're going to go for page in line dot split comma, I believe what it is, and then we say let pages equal new vector page let num equal page dot parse. I think it's EU32 dot unwrap because I'm not in the mood to write good code now. We're trying to get through this just to catch up on some of the days. Pages dot push num. Right, and then we get to the end here. We're going to say update dot push all right, one thing we need to check is go, hey, is there like an empty line? There is an empty line, so we need to go if line dot trim dot is empty. Okay, so then we need to go this. So we need to go that new words equals line dot split at the pipe, like so, and then we say let sum first equals words dot next else continue. We need to say an error or some description. Okay, and then do exactly the same thing, but this is okay. Those seconds. Okay, then we say same as you, let num equal this except you're passing first and second, and your num1 and your num2, and then rules dot push num1 comma num2. Not comma, or yes, comma, tuple it. Okay, so right, so that should parse all our data fairly easily. Okay, so next we need to decipher the page rules. So I think first we kind of want to say rules dot sort by A, B, A dot 0, A dot B dot 0. A reference to B. Okay. So I don't know if that's the correct ordering, so we're just going to go print line and we're going to print out the rules. The idea is I want the rules in order so that when I iterate through the pages, I can sort of just continue early if the rule is greater than the value, just so I don't have to keep searching. Like, I'm using Rust, so it's not like speed's really a problem. I use it fast enough, but wait, why are you rendering the picture? Did I set that wrong? 5? Day 5. How is that working? No, day 4. Did I fuck up day 5 somehow? Ah, yes. If I hold it that the advent in advent 5 is actually advent 4. Okay, run that. Okay, 5. Then we go 1, and you should print out a whole bunch of things and go, hey, are these in order? 11, 11, 11, 11, 11, 11. That's lots of 11s. And then it goes 15, 15, 16, 7. Okay, so that's in the correct order. That's the smallest to largest. Okay, so next we want to go for page in pages. They're not called pages. Update. Okay. We're going to say let me success. Equals vector. Okay. So to do this, we need to go through the page, and we're going to go for pages, for page in pages. Okay, so this is an individual value. We need your index as well. So I pages dot iter dot enumerate. Okay, so we have the page. We need to go. Okay, so we need to go for rule in rules dot iter. Right. So if page equals rule dot 0, do the rule. Else, if page is greater than rule dot 0, break. Okay. Right. So the way this is working is we're basically going to execute the rule if it's equal, and if at any point the page is greater than the rule. No. If the page is less than the rule, because the rules start low. So if the page is 60 and you're on rule 11, you want to test it until you get to page rule 60. But if you're on like rule 11 and it's like, hey, page 60, it's like, well, you've already passed all the rules that could possibly apply. So now we need to apply the rule. So the rule is going to go, rule goes for, we need to kind of iterate through each page. And we get to here, we say success.push pages. Right. We need to say, is it like this? I think it's like this. So we're going to say for hold in 0 dot dot I. So these are all the pages that have already been passed. If so it's like old equals pages old, like that, and then we say if old equals rule dot 1. So if it's a page that has to come after a previously, if the page that we're looking at is supposed to come after the current page, then we're incorrect. So we say continue out. Right. So expected view size. Okay. Wait, that's that. Well, this doesn't like that. Okay, so if the current page is equal to the rules page, the rule applying, go through all the pages that are before the current page, then get the page that we're looking at. So iterate through all previous pages. Then if old is equal to the first rule, continue, because it means you didn't meet the rule. I mean, that should work, shouldn't it? I don't know. And then we get to here and say, hey, if you manage to get to here without returning early, which is like if you didn't hit a rule that was, if you didn't break a rule, add it to the list, and you break that loop, which is searching the rules, which then we go to the next page. Okay, cool. So then next we want to print, we go 4 pages in success. We want to say, okay, let mid equal pages dot len divide by 2. Now it assumes that all updates are exactly equal in page length, but we'll find out. Then we say found plus equals pages mid. I have no idea if that's going to work. We filter out successful pages only. And it seems like a really simple problem to solve. It's so much easier to solve when you're not trying to do data visualization, because there's so much extra data that I need to extract in order to visualize something out of it. Whereas I'm literally just like, hey, filter it, chuck it away. Whereas before I'm like, I need to keep track of everything so that I can do that. Now, hey, I reckon that the answer is 4,872. Let's find out if that's correct, because for all I know, I'm boasting I haven't even fucking solved the puzzle. So let's paste that and go, hey, is this the correct answer? Yay, okay, got the right answer. So I'm going to solve this final one, and then we'll do it. We'll try and come up with some kind of data visualization for this, and then I'll call it a stream. If I can't come up with a data visualization, at least we've made progress on at least one more day. So, okay. So when they always get the printer working correctly ordered updates, you have a little time left to fix the rest of them. Okay. For each of the incorrectly ordered updates, use the page ordering rules to put the page number in the right order. Okay, for the above example, here are the 3. Okay. After taking only the incorrectly ordered updates and ordering them correctly, then after taking only the incorrectly ordered updates and ordering them correctly, their middle pages are find the updates which are not in the correct order. What do you get if you find the middle page after correcting ordering just these updates? I like that it's so explicit, like bolds it, like, hey, like these will trip you up and they're not actually part of the question. Well, like they're part of the question, but like these will trip you up, but they're not part of the challenge. They're literally just you don't understand English, which is like the best. So this one legitimately might just be, I guess it's every time, and I fucking end up changing so much. But like this one, I need to parse it and be like, hey, we have success, and then we also need to like go, hey, let mute fail equals a vector new, right? So, and then we go, hey, if you get here and you say, hey, when you continue old, can you say failed dot push pages, I guess. Like, that's it. Modified. It holds the failed. Okay. Now the hard part is, so we found the middle, and so we can get rid of this part because we don't care about the success. We probably don't even need to collect the successes. We should probably just get rid of that. Because like this is supposed to be part 2. Anyway. So let mute found. Okay. So rules sort by. Okay. So to do this, we need to go how do we do this not repeatedly? The thinking, because what I could do is find the rule that's wrong and then flip those 2 values, but that's likely to just invalidate more shit. Because what I'm thinking is like I could do like a while true, but it could take fucking forever, as it'll like bubble sort the way through of like if I just move the page that needs to be behind to behind, and like do that constantly, but I'd have to recheck it to make sure I didn't invalidate a different rule, because if I'm just jumping it to that position, may as well. If I can let so while failed dot len. Okay, so we're gonna get like let mute success equals a vector. Right. So these are the ones that have since succeeded, and then we're gonna say mute next equals so we need to make this just a vector. This is going to be really inefficient. Right. So we're going to go while fail.length is greater than 0. Okay. So the last thing we're going to do is come down here and we're going to say std mem swap mute next and mute failed. Alright. So we have to find the point that it fails, which is this code again. So this is going to be really weird. So for page in pages, okay, so pages. So while pages is for okay, so let now. I guess is it pages? Pages equals failed.pop. No, maybe it's 4 pages in fail.drain. Is that going to work? Is this going to yell at me with the compiler complaining? Doesn't seem to. I'm trying to like drain it so that it's, but I don't think iterating works. Because like iterating through it won't empty it. Right. Removes the specific range. Can I just remove everything, please? Okay. That should work then. All right. So for index in pages. Okay. So what we need to do is we know your current index. And then we go through and we go, hey, I know the index of old. So right here, right at this very instant, we call you failed. So first off, we're pushing you on next. But you need to be mutable. So I feel like all we need to do is, again, it's somewhere down here. 4 pages. We say success dot push pages. Like that. Yeah. Then you continue. No. You need to. You're called out. Okay. So we need to go here. We need to go like you continue. Out. Right. So go to the next page. Okay. So next gets pages added to it. So that's basically a list of failures. And in theory, this would never end because we aren't modifying pages at all. So next we need to go pages dot remove. This returns. Okay. So we need to remove I. I is the current page we're looking at. Remove the ith page. Let page equal. Remove the ith page. Technically, we know what it is, but in this case, we're actually physically removing it, which it shouldn't let us do because we're currently borrowing it, but we'll just ignore that because I think it's going to complain though. Right, then next we say, hey, if you've removed page, I will because it's a clone copy. I don't know. Why are you letting me do that? Anyway, so we have our page, and then we're going to say let old. So we're going to say pages.insert. Right. and we're going to insert at the index of old, and then the element is page. Right. So, what do you fucking mean? Oh, we know we need. There you go. So basically, the rule that breaks the page that breaks the rule. Page that breaks the rule. So this page breaks the rule. We take that page out, and then we stick it as close to the page that that causes it to break as we can. Basically, we push everything past it out, and we insert it in the end. Right. The reason that this is good is because it means that, and then we check it in the list to check again. And once we check that list, once that list is empty, it means that there's no more out of order lists because we've checked them all. And then hilariously, this code ended up looking more like the original code as well. So for pages in success, let equal mid equals pages dot len divided by 2 found plus equals pages mid. So like so. Okay, copy to advent. Okay, fine. Not is empty. Okay, so there's something in the failed list. Drain the failed list. Iterate through all of the pages. If the page breaks a rule, iterate through every page, iterate through every rule. If the page breaks the rule, set the page in a different position and continue on the next set of pages, because I mean, you've reordered it, it needs to be checked again, because otherwise we'll lose track of where the indexes are and we'll have to fucking. So this is going to be incredibly inefficient. Incredibly efficient. Anyway, okay, and then and then this is where we check it. Okay, here we so I suspect again we're gonna have another like nice simple first try approach here of it seems pretty straightforward. It's terribly slow. Like this in Python code may not be a very good idea, but in Rust code it should be fine. We're just iterating through 5,564. I don't know if it's right. We'll find out. Yep. 5,564. Okay. Well, that was that worked. That's cool. How to visualize the data now? That's the issue. We're gonna be blank canvas. How are we gonna visualize this data? First off, this data is an XY coordinate, so like that's not gonna work. Could I do like a sequence of gradients? I don't know. Kind of. So what we would need to visualize this is sort of like we could assign every number a color. If we assign every number a color, and then we can assign each update a row. Kind of want to visualize data. We could do one where one is just the data visualized and 2 is the data sorted. That could work. So what we'd need to do is somehow work out how to convert any arbitrary number into a color. The other issue is how fucking close do the numbers have, like, what is our range? Are they 0 to 100? Looks like 0 to 100 to me. Okay, Cool. So they're never more than 2 digits. And they're all varying lengths, which is interesting. Okay. So that should be fairly easy. So the fun thing is to go, hey, 5. Do you, by any chance, set up map? No. But I think we want to copy 4's image handle bullshittery. Right, like that. And then we want to put day 4 and be like, hey, copy just all this bullshittery. I don't know why a giant white square appears. You're yelling because I've got it duplicated. Oh, because I'm spawning a sprite, but I'm not giving it a handle. Okay, so now you're actually going to spawn in a transparent or an invisible square. All right, so then when we parse starter 1, so we're going to want, like, yeah, the first one, we can just pass all of the data. So it's value between 0 and 100. So maybe, like, we could set the greenness. Let's do other colors than red and green. Let's do okay. Color wheel code. Let's get ChatGPT involved, actually, because that could be interesting. I've discovered that ChatGPT is actually really good at coming up with, like, simple things as long as you're, like, able to understand what it's trying to do in the first place. Somewhere ChatGPT to re-sign in my session. That's why I have it open in my other monitor so I don't dox myself when I sign into my real human account. There we go, new chat. I'll bring this over here so you guys can see. So we're going to say, can you write me some Rust code that takes a number, U30, between 0 and 100 and returns color each number should okay, returns a color returns, I guess, 3 floats, 3 F32 a color on the color wheel. Each color should be unique. I'm asking the wrong question because really I'm trying to ask it to generate me a color wheel code. Each color should be unique and numbers close together should be similar in color. Let's see what it comes up with. This is not the right question. Here's a Rust function that takes an EUA between 0 and 1 and returns 32. So pi. Yeah, okay, hue. Oh god. Oh god. So what the fuck? Go away. Go away. Okay. So hue reigns times pi. Okay. Fuck it. Okay, map the input value from 0 to 1 to a hue of 365 degrees. Convert the hue to radians for smooth transition. Okay, it's just times pi. Okay, so I'm just going to copy the code wholesale because I have no idea if that's going to work, but we will find out. So bit down here. We're going to modify it to return a Bevy color, but we're going to say FN color wheel. So we're going to first off change this to a U32. Just because I lied to it and said it was a U8 just so that it would not write code that specifically expected lots of colors. Then you're going to return a color. And you're going to be returning a color sRGB. Okay, cool. That should be fine. That's where we try to find out what it looks like. When in doubt, ask ChatGPT. You know, it's a good way to write code when you have no idea what you like creativity wise. ChatGPT is pretty good. So we wanted to pass data one. We go, okay, so when you're passing the data one, you iterate through the lines and you do that. So it's got to be when we're doing the page sorting. So first off, we need to know the updates I. So we need to modify this to have PI. It's different to pi. Enumerate. Enumerate. Okay. So we have PI here. Okay, so we now know your I. So we need to get the image, which means we need the fucking image. Just image res image handle like that, and then we say let okay. Oh no, it's just image equals images dot get mute image dot id image dot zero dot id. Okay, else return. We should just say unwrap, because unwrap is better in the situation than returning and not knowing why it failed. I would rather it panic. Thank you. Okay, so we now have access to our image. Oh, no. Cool. Okay, so we have access to our image, and then we go, okay, so we know how long updates is. So LW, let LW, LH, line height equals height divide by not success. Well, we only iterate through success. Oh wait, no, we don't. We update through. So divide by update dot len. And I need you as no, as users. Okay, so that's the number of pixels per line, right? And then we need to go. I think it's here. We say LW equals LW is the same as width as user size divided by pages dot length. Okay, right. So we then need to go for each page. So I guess we can say L line start is equal to LH times PI. LE is equal to LS plus LH. Should name these properly because it's getting already confusing. So this is just rename line underscore start line underscore end pixels line PI is still technically PI, so I'm not going to rename that. So then we're going to say, wait, this is pixels per page. Okay. So the next we can say let page start equal to pixels per page times by I, and then let page page underscore end equal pixels per page. No, it is page start. I guess pixels per page plus page start. It's just the equivalent of I plus 1. So then we say, we iterate through the rules. We don't care what the rules. We just data visualizing. So for x, y in, okay, so for y in line start dot line end, or y in x in page start dot page end, image dot set color at x as u32, y as u32, color, and then we say let color color equal color wheel page. So yep, okay, that color there, run that code. All right, kind of interested to do that. So I kind of want to do the same thing down here. It's all the same, except down in this visualization, we're only going to do it to here. Which I mean, guess we technically have to do it when we get to success. So it's pixels per line is success dot length. Right. We need to also do the page extraction bit that way. Right, that bit. We need to come up here. Okay, yeah, here. And then we need to say, you have images and we need image. Okay, so something's gone wrong because I copied not enough closing brackets. Okay, so we don't use out, you are success, but you are just iter. Just iter. Alright, iter and array. So that this page is, so that's equal to success length and then page length, and then so there should be an order this time because that's after it succeeded, and then we run that. Okay, so let's see if that visualization code works as I expect, and we'll see what ChatGPT can pump out as just a random fucking color generating code. Well, apparently it doesn't do anything. Well, that one generated some fucking weird ass colors. That one didn't do anything. So 1 just doesn't work, but 2 does. I feel like that's not actually following the rules I set out. Because they should start like red and go green. Or go through green and then go to blue. Like, that's not ordered. So, first up, why is 1 not working? Maybe it's because there's a lot of pages. can we change width to being like 1,000? Because again, Bevy will crush it onto the page, which means that as long as it's not rounding to 0, Bevy will make it fit because we've given it a specified size. It's that it could be dividing by a number and it's just so big that it's getting 0. I wouldn't think it would, but okay. That's looking much nicer. Yeah. So bizarrely, it seems to be like scribbling on top. So I'm definitely doing something wrong. Probably when I'm calculating. I didn't change anything, so I don't understand. Like, they would fucking copy paste the same piece of fucking code. Pixels per line is height divided by update.length. Okay. Pixels per page. Page index. Page index. Line start, line end. Question is, does Bevy have a hue saturation? Like, can I not just say color, hue, saturation, lightness, and then just pass in hue, a saturation of 1, and a lightness of, I guess, 1. Just please return that. Ignore whatever ChatGPT was fucking cooking up. Oh, wait, we need to leave the fucking convert. Cool. I legitimately don't know why it works on one but not on the other. So parse data 1. So something about you. So you are pixels per line is the height. And that's our y. Line start, line end. Okay, which is pixels per line times pi, and then that one's not the problem. It's page start, page end, pixels per page, which is the width divided by the page dot length. And then your current page here. Okay, let me see setting. Fucking, I don't know. I legitimately cannot understand how I can copy paste the code and it works in one copy and on the other. Okay. Okay, now it's not working at all. It's probably because the saturation is... So... One of these is... What are we going to do? Go here and go, hey, hue, saturation, lightness. Okay. So, if I pick like a really bright green, saturation is at 100%. Right? Like, that's what I want. If you're cycling through nice bright colors. V. Hue, saturation, V. Maybe it's because I've set lightness to 1. If you can't set it to fucking 0, it'd be black. Hue. Okay. Hue, saturation 100%. Do we learn like a lightness of 0.5 maybe? Like what the hell? This is something the editor can't help me with because it won't let me edit individual pixel colors as a hue, saturation, lightness. Okay. Well, they're at least colorful now. Okay, I don't understand why. Like, you clearly only have a few values. Potentially, it's because they're out of order. Because they're sorted and they go to the end. No, because they should just change the color. Like, they're equally spaced as well. Like, so it's clearly adjusting for the fucking... the number of them. Ah, I bet you know what that is. That's because I'm returning early. You know what? Great visualization. That's me returning early. Because I'm doing the coloring inside the function. Like, while I'm sorting the data, like while I'm cleaning the data in update. Nope, this is... yeah, in the updates, I'm coloring it while I'm going through the updates and seeing if they succeed or fail, which means if I return early, I've calculated the width of that bar based on when it should return early. Hence, this one succeeds because it's already succeeded and like they will all not return early. Technically not actually, I'm just iterating through it, but like it's what that's visualizing. So this is, they're all sorted, they all make it to the end, they're all successes. Whereas here, if they make it to the end, they're a success. Mind the rounding errors. If they don't make it to the end, they're a failure. So like this one made it 3 steps and then it failed. I don't know how long it was. Like you could calculate it because it's what, it's 3 and then you could put another 3, so it's 9. That's like 15 long, but only 3 of them succeeded. Like that's just, each of these lines that doesn't reach the end is a failure case. Whereas this are all successes. Now it is kind of funny that it doesn't clear the fucking image, which we then draw on top of each other. Which I don't know if it's better or worse. I gotta err on the side of fucking worse. So dumb. Also, I don't understand why that one doesn't go all the way to the bottom. So like a whole bunch of the ones just fail down here immediately. Like they don't even go through the one step. Why do you not go all the way to the bottom? Weird. Okay. So what that tells me is I should probably just put a little bit of code in that clears the fucking image when you... So what is it? It's probably something like FN wait, is this something I can, maybe there's a, maybe I can just call fill, like maybe there's a pre-made function for this, so we can say image dot... nope. Okay, thank you. Okay, so this needs these, and it needs to do this. Okay, and then for y in 0 dot dot height, for x in 0 dot dot width, for image dot set color at xy, and then color is white, black. We don't have a flashbang, everyone. Black. So the default color is black. Okay, and then this happens on enter. It's more like on exit. Yeah, like dot add systems on exit puzzle state puzzle. Let's just say on 2 and then we'll just fucking clear image. It's only exiting image 2 that's a fucking problem. So we'll only bother actually cleaning it up on the specific image that it's a problem. And we go back to 1, we go 2. So it does look slightly different when you flick back and forth because it clears it with black, but okay. See, because we can't clear it with black because the way I'm initializing the data is I'm initializing 0. Take that. Okay. We initialize with 0s, and that means that the opacity is also 0, and I don't know how to initialize it with a 3 zeros and a 4, 3 zeros and a 255, 3 zeros and a 255. Like, I don't think that works. So anyway, thank you for tuning in. That will be the end of today, where we did 3 full days of the advent of code. Hilariously, the 5th day went way faster because I solved the code and then did the visualization instead of trying to work out the visualization and solve it at the same time. That or it didn't go faster and it just felt faster because I actually like made progress and then swapped onto something else. My progress brother was like slam mad against the wall trying to fucking solve it and visualize it at the same time. But there'll be another stream hopefully sometime soon, maybe this weekend again, or if not next Friday, where I'll continue and do more advent of code and do some more of these projects because they haven't got too hard yet, but knowing my coding skills, we'll get today like 6 and it'll just hit a brick wall. But yeah, thanks for tuning in. Like, comment, subscribe, whatever you do at the end of a live stream, I'm not sure. And I'll see you then. And we're gonna go here.